Hi everyone. Good afternoon. I can still see a lot of you trickling in, so I'm going to wait for a couple of minutes. Okay, so thanks for people who joined in early. Awesome to see you guys here. Our speaker is already in the house, and we will start very, very soon. So till the time everybody is joining in, I'm gonna go ahead, share my screen, and we're going to get started. Yep. So I hope you can see my screen. If anybody in the chat can confirm. Yes. Okay. Yes. Thanks, Gulfam. Thank you. Awesome. So, guys, welcome to day 2 of the AI Launchpad that we have organized. Most of you would have joined in yesterday also. And before I start the session, just want to do a quick check of if you can see my screen, hear me clearly, and that would be helpful. So, can you hear me clearly first? Yes, yes. Okay. Yes, lots of yeses coming in. Awesome. And you can see my screen also, I'm assuming. So Hema, you asking, can we get yesterday's recording? Yes, I'll tell you all of the updates from yesterday and where you can find the recording of yesterday. So don't worry, you've written you had a medical emergency. Hope things are better now, and we'll start soon. So yeah, let's answer all of the questions that you guys are asking, and let's start day 2 of the AI Launchpad. Welcome again. All of you, most of you have joined in, so I'm going to start it. Uh, Yesterday, we went through a lot of topics, while the base of all the topics was talking about a multi-agent customer support system. And we Justin touched upon from the basics to how agents work, what are hallucinations, how to put in guardrails, all of that. A bunch of things were covered on day 1. So if you were there, great. I'm sure you would have enjoyed the session. If you weren't, I'll tell you where to find that session. And after today's session, you can go ahead and watch that video. Okay. So day 2 is also equally packed. Okay. So we are going to move on to more advanced version of what we were discussing yesterday, so that we can close the loop on this whole topic as such. As the topic of the master of the event suggests, it's an AI launchpad. So both the days will help you get started in some form or the other. Okay. So before we do that, while some of you, yesterday Moin was moderating this particular yesterday's day. So today I'm the one in charge. So some of you already heard about IK yesterday, and today I'm going to repeat that for the benefit of people who weren't there yesterday or missed it out in the beginning. So Interview Kickstart, as some of you already know, but for those who don't know, we have been doing this for over 12 years. It's written 10, it's actually our 12th year now. We started off in the Silicon Valley, and about three and a half years back, we came to India with our offerings. Our offerings particularly are uh, all about AI ML up leveling plus interview preparation for domain specific technical professionals, right? So we cater to about and customize our offering for about 18 tech domains. So for example, for a backend, the track is different. For a TPM, it's different. EMS different. So we cover about 18 of them. I'll talk about this a little later more. I want to hand it off to Justin as soon as possible so that he can get started. We have a base of about 27,000 learners already, and this is India and US across. You can see some of the success metrics on your screen, what kind of outcomes our learners have seen. On an average, any of our instructors have about 13 years of experience, and these instructors are actually our secret sauce. And for example, you're going to see a very good sneak peek today in the form of when Justin takes over, because these instructors are people who are actually building and scaling AI ML systems in Mang Plus companies at the moment. So whatever they learn in their day job and are building, they come and teach you all about it as per your domain, right? So there's a great transfer of knowledge that we are able to do. Like I said, most of our instructors currently work in names that you can, or logos that you can see, company logos that you can see on your screen. And they have a vast experience. Now, talking about vast experience, I want to introduce Justin at this point of time. So he's a homegrown person, studied in BITS Pilani I think about 10, 11 months back. He moved to Ireland with the analog devices as a staff AI engineer. He has about a decade of experience in just working in AI, which I think is an amazing repository to sort of learn from. So make the most of it. I know you guys have questions on recordings and joining our community links on Slack and Discord. All of that I'll keep posting in the chat, so don't worry about that. I'll want to know you guys a little bit, so I'm going to launch a poll as Justin introduces himself. So Justin, over to you. Uh, but don't worry about the recordings, guys, or slides. I'm going to share all of that in the chat. So sit back, as they say when we take off in a flight. Sit back, relax, and enjoy the flight. Enjoy the session. Focus on getting the most out of the session. Okay, over to you, Justin. Welcome.
Right. Thanks, Niyati. Give me a moment. Let me just share my screen. All right. Hello, everyone. Good morning. Good afternoon, and welcome to today's session on AI Launchpad Day 2. So we'll be covering some of the topics that we dealt with yesterday in more extensive detail, in a more deep dive fashion. So that's the objective of today's session. So if you had not attended yesterday's session, today's session might feel a bit disconnected because we would be exploring into the functions, into the different aspects that we discussed yesterday. But it's fine. I'll try to give a high level overview about whatever topics that we are going to discuss today from a perspective in such a fashion that you will be able to understand it more or less, even if you are starting from scratch, even if you did not understand, sorry, even if you did not attend yesterday's session. So, with respect to yesterday's session, I hope that you got some time to go through this. Oh, sorry, not this. To go through the repo, and after going through the repo, I hope you did make an attempt on implementing this. And I hope you got a chance to run this on your local system. And I hope you also got a chance to deploy this on Hugging Face spaces so that you will understand how to get this up and running. So today we'll be discussing about the internals as to what this multi-agent customer support system is about. What are the different guardrails? What are the different mechanisms that use to ensure that our LLM is grounded, or our LLM responds to the user's queries purely based on the inventory that is available, inventory or the data that is available in our database, and ensures that our LLM does not hallucinate or minimizes the hallucination by having proper guardrails, by having proper system prompts, by having proper mechanisms ensuring that we have specific schema for different tool calls, for different tool call input generations, and all of this by the LLM. So, as a quick recap, we were talking yesterday about, give me a moment, let me just pull up yesterday's slides. So, give me a minute. Yeah. So these were yesterday's slides. So yesterday we were discussing the multi-agent orchestration system, and the objective was that your system was capable of providing four capabilities. One, you have information about music catalogs, and you have information about the customers. Now, the first capability was to browse the catalog. So you have different genres, different artists, albums, songs, etc. So if a user asks a question as to what are the different rock songs or rock albums that you have in your catalog, then it is going to list you like 20 plus rock songs, and it is going to tell you that we have around 1,300 rock songs, and these are just 20 of them, just so that you can get a feel of it. And then verifying the identity. So whenever a user is trying to interact with us, especially when attempting to get the past information about the user, like for example, the purchases, invoices, etc., it needs to validate or verify the identity of the user. Because if you and me are the users, I shouldn't have access to your information. You shouldn't have access to my information. So there is a verification of identity that is happening by asking the user what the credentials are. For instance, it could be email, it could be phone number, it could be your user ID, etc. So, irrespective of what is being input, the LLM should understand whether it's an email, whether it's a user ID, whether it's a phone number, and then based on that, after converting it into a standardized format. For instance, if it's a phone number, you are to convert it into a specific format based on by removing the by adding or removing the international code, removing spaces, and all of that, and then performing a check with the database and then fetching the corresponding customer ID so that the identity will be verified. Then we also ensured that we have access to account data. That means past invoices, past purchases, billing details, etc. And also the support representatives that assisted your purchases would also be available in the past account information. And then it is also capable of providing you personalized support. For example, if you tell that you are interested in rock music, and then 2 days later you tell that you are interested in pop, then it won't erase your past interests, but rather your new interests would append to your past interests, now saying that you are interested in both rock music as well as pop songs. So, this is how the personalized support works. And based on your interest, it is going to provide you personalized recommendations, suggestions, etc. So, this is the real world use case scenario that we built a multi agent system to tackle yesterday. And we were talking about what are the agents, what are the tools, what are the capabilities within each agent, what do we mean by a supervisor agent, all of this. So this was what we discussed yesterday, and we discussed some aspects of lang graph, like the state graph. Hold on, like the state graph, the nodes, edges, etc. All of this is yesterday's topics, by the way. Now, we were talking about the different agents, right? So this is about the data set that we have, which is a Chinook data set, which consists of multiple information about the tracks, records, users, past invoices, etc. So yes, so regarding the agents, first we had a supervisor. You can't call a supervisor as an agent, but rather supervisor is more like a router that routes it to the correct sub-agent. So given a user query, it understands what the expectation is, and based on the expectation, it routes the query to the correct subagent. And with respect to the subagent, we had the music catalog subagent, like I told you, to get information about the albums, records, etc. Invoice information subagent in order to get information about your past purchases, billing, etc. Then it could be a combination of both. So your question could be about invoice as well as music. So the trigger would be in such a way that the invoice subagent would be triggered first to fetch information about the invoice, and then the music subagent would be triggered because some information might have to be fetched from your invoice, which requires your invoice itself. So invoice is first pulled, and then the music is pulled. And then if any query is coming beyond this, then a standard template response saying that I do not have information to provide you regarding this. That is what's given to you. So these are the different subagents that we had. The two subagents, music catalog and invoice information, and the supervisor was there in order to route this. Now, we also discussed the reasoning plus action, which is the React system. And we also told how we wrote the React system. One subagent, which is the music catalog subagent, the React system was hand built, or we wrote the logic for the reasoning plus action. And with respect to the other subagent, um, one moment. With respect to the other subagent, yeah, the invoice information subagent, we used a pre-built React using LangGraph's create React agent function. So it's a pre-built function that we can use to create React functions depending on our requirement. So why we took two different approaches was because we wanted to show that the create React agent has its own limitations or its own constraints because it's a pre-built function for you. But to get started with, it is an easy way. And on the other hand, for the other sub-agent, we wrote our own reasoning plus action logic, and that enables complete customization. So it totally depends on what you want. And if you do not want a lot of customization, just go for the pre-built functions in LangGraph. And that is exactly why we prefer to use predefined frameworks like LangGraph, LangChain, True AI, Autogen, etc. Otherwise, you will have to write all of these from scratch. And there are a lot more other topics for agentic systems like MCP, for instance, which were not covered in this particular use case because we have time constraint and we are not here to cover everything, but rather whatever we are covering, we are trying to cover it in such a fashion that we can convey as much as possible to you. And I see a lot of questions coming in the chat. So if you have a question, please ask it in the Q&A. We have a TA who is going to support you with answering the questions live. And I see that, oh, wait, don't we have a Q&A option? Yeah, we have. I see some questions that are open and I see some questions that are answered as well. So please ask your questions in the Q&A because if I have to take up questions, I see that we have a sizable cohort and we have limitation with respect to time. So I won't be able to cover all the questions. But periodically, I'll try to pause in an attempt to take up a few questions whenever time permits. All right. So this was what we discussed yesterday. And a quick recap, an agentic system is not an LLM, but an agentic system is a system that is built around an LLM. So your LLM will be the brain that thinks what to do, how to do, etc. And the LLM will have connection or will have access to tools, databases, etc. that it can decide to trigger whenever it feels that, okay, triggering this tool will provide me more information. And based on that, I can give a more comprehensive answer to the user. So this is how an agentic system works. So as per the analogy that we discussed yesterday, perceive that agentic system like a human body, where the brain is the LLM, and the hands, legs, and anything that can help the body achieve something are the tools, databases, and all of the connections. So even your chat GPT is actually an agentic system, not an LLM. Your GPT-4o is an LLM, but chat GPT is beyond an LLM. So if you ask a question to chat GPT about the weather right now at your place, it is going to answer it. And it is capable of answering it because it can trigger something like the weather API or a Google search as a tool in order to fetch the correct response back to the LLM. And the LLM can then provide the answer back to you because the LLM was not trained. He is not trained every single hour, every single minute, every single day. Probably the LLM that we are using in ChatGPT might have been trained 3 or 6 months back. So it is still able to understand what's happening, or it is able to respond to respond to the current affairs or the current questions purely because it has access to some tools that can fetch information for it. And also, we also talked about the fact that LLMs are stateless. That means LLMs by default Okay, LLMs by default do not remember what happened in the previous conversation. So what you need to do is to provide something called a state, and we call it memory, by the way. The memory can be short-term memory. That means keeping information or keeping a track of the current conversation. Or the memory can also be long-term. Like for example, ChatGPT knows what kind of person you are, what your occupation is, probably what your salary is, what your relationship status is, all of these stuff. So that is long-term persistent memory. But short-term memory is the information about the current session that you are having the conversation with. All right. With all of that in mind, so let's go to day two. Day two, we are looking to deep dive into what happened yesterday and a deeper analysis on the different aspects of the agentic system that we talked about yesterday and that we saw yesterday. By the way, if you decide to implement this, sorry, if you decide to implement this, one moment. Proper instructions are given here on how to deploy it on your local system. If you're interested in just checking out by running it on your local system, and this is how I've spun it up on the local system. So you can see that it's localhost, it's my local system. And I can ask questions like, let's see, what rock albums do you have? I don't know whether it's working right now. I didn't check it. Let's see. Oh, first I need to verify my identity. So it says that um, my customer ID is 5. What rock albums do you have? Let's see. So currently you can see that there is a processing going on. I'm pretty sure that it'll come back with the answer because it's taking a lot of time. If it simply had to say that it does not know what it has to say, then I don't see a point that it has to take this much time to respond. See, It came back with the rock albums pertinent to the database that we passed. And it says that here are some of them. And then it says that in total we have 1,309 rock tracks in our catalog. And if you remember, when it was waiting for the user input about verifying the identity, what happened was if it mandatorily requires my identity, like for example, if it has to pull up the invoice, for instance. By the way, it did not ask for the identity. It was my incorrect comprehension. It did not ask. It said that you don't need to verify your identity to verify the music catalog, to check the music catalog. And I comprehended it incorrectly. So even if I did not give the customer ID 5, it's going to be fine. It would have returned me this. All right. So if I have to pull information based on my invoices, for instance, then I'll have to give customer ID. Otherwise, it will say that what customer are you? Validate it first before we can pull up invoices for you. And at that time, if you remember, there is something called interrupt being triggered in LangGraph where everything comes to a freeze, to a standstill, while waiting for my response as to what my customer ID or my customer identifier is, so that it can resume operations the moment it receives a customer identifier. And this is the local deployment, and it was also deployed in Hugging Face Spaces. Hugging Face Spaces. So you can see here that we are talking about this one, Spaces in Hugging Face, which is a platform which can be used to deploy your machine learning or any applications that you want. So you can use any kind of front end that you prefer, and we are using Gradio for front end. So you can use the same thing here, and it is going to run it in run it in uh, production here. So we are productionizing this in Hugging Face Spaces, and the instructions on how to productionize in Hugging Face Spaces is also given. This is about the local, and deployment is also given in the same README file. So wait, deployment. Yeah, here. In Hugging Face Spaces, the instructions are given here, so you can just follow that. In fact, these instructions would be more than sufficient for deployment if you do not want a Dockerized deployment. All right, let's get back. Let's talk about today's topics. So I hope that was a sufficient recap for you. If you have any questions with respect to the recap as to what we did yesterday, please ask in the Q&A so that the TA can respond to you. Because I won't be able to take up questions in the chat in real time. That's why. If you still have questions, it's fine. When we take the questions up, you can ask the questions in the chat. All right, let's get started. So today we will be discussing about the advanced internals and production and how to productionize this, because currently we have a setup, and in order to productionize this in a production grade setup, there are some changes that we have to make it more robust, to make it more observable, to ensure that it scales properly, to ensure that there are proper CI/CD pipelines, etc. So that is what we'll be discussing today. In the interest of time, we won't be able to implement all of this because we have very limited time. So, which is why design considerations or how you can possibly take it up for a very good, production level, in enterprise level production grade system is what we'll be talking about. So, we'll be going into some aspects of the code. We'll be talking about how to orchestrate the solution. We'll be talking about observability. We'll be talking about scaling as well as making this production grade. All right. So let me just skip all of this. Yes. So we just had the day one recap. Mm, yeah. So today we'll be covering multiple aspects like deep orchestration, database deep dive, accuracy and validation, managing the states, logging and observability of the agentic system, handling errors, making it production grade, ensuring persistence, scaling, and ensuring some security aspects. Then ensuring that there is sufficient performance and it is reliable and it is scalable. Then certain architectural decisions as to why they were made. And also a look into some of the important aspects of the code and also the future roadmap. And we'll be covering the hard interview questions with respect to this. All right, let's get started with the deep orchestration internals and starting with a quick recap. So we talked about the state. So let's take it one by one. So when we talked about the state, yeah, here. All right. So do you remember what the state was? So the idea was that we had the state messages. And if you remember, this was like our whiteboard. And in the state, everything about the customer ID, about the messages, about the memory, about the remaining steps. Everything is there on the whiteboard. So you can read and write to the whiteboard. And that was what state was about. And then we talked about the reasoning plus action loop, the React loop. So the React loop's idea is that, see, the has LLM knows that there are tools uh, that can be accessed by the agentic system. Now, the LLM has information about the tool, the name of the tool, the capability of the tool, when to call the tool, what kind of inputs are required by the tool, etc. Now, given a query to the LLM first checks, can I answer this query myself? Do I have adequate information to do that? Most of the time it may not. Like for example, it needs information from database, it needs information from uh, probably by calling certain tools that it has access to, etc. Now it figures out that I don't have all the information. Can I get the information by using any of the tools or the databases that I have access to? And then it takes a look at the definition of the tools or the databases, and then it decides, okay, let me trigger this tool. And that tool is triggered. The tool, in order to trigger the tool, it needs, one moment. I'm seeing some issues with my internet connection. Let me just switch it. There was an issue with my internet connection. I hope you can hear me properly now. If you can't, please let me know. Are we good? Okay, let
Yes.
me continue. Perfect. Okay, so what I was saying is that the React loop. So it needs to decide what tool is to be triggered, but not just the decision. The LLM needs to take the input from the user query and then consolidate the user query in a particular format so that that format can be passed as an input to the tool. For example, the tool would be a function which requires a JSON in a specific format as the input. So the LLM's responsibility is to take the input that it has, convert that into the JSON format, and then feed it to the and then hand it over to the agentic system, and the agentic system is going to trigger the tool using that input, and the tool gives back the output using the input, and then the output from the tool is fed back to the LLM. Now the LLM says that, okay, I have all of these information. Do I have adequate information to respond to the user? If yes, it responds. If no, it decides what other tool to be triggered. So this is the reasoning plus action loop. So yesterday I had also shared one very good YouTube video that walks through what reasoning plus action is and how you can possibly implement it by just using a system prompt. Also on how to implement it using LangChain. So let me just share that link with you once again. Um, one moment, I'm just trying to find it. Yeah, got it. So I'm just sharing it in the chat. Yeah, this is the link for the React reasoning plus action. And also, some of you who might be joining today might not have access to the database. Sorry, GitHub repo. I'm also sharing the GitHub repo in the chat. All right, let's continue. So we talked about the React loop, then the memory system. So if you remember, storage of memory, two ways. One, ephemeral memory, which is your current state, or not the current state, current session. So you're having some back and forth with the chatbot. So that back and forth as to what is happening right now should be stored in an ephemeral memory. That means it needs to understand what is happening, what happened previously. That is the part. Second, the persistent memory or the continuously stored memory as to what the expectations, sorry, what the preferences of the user are, what kind of user is this, etc. So those information is stored in persistent memory. So these are the two memories that we discussed yesterday. And then there is the graph order. We had discussed that when the chatbot starts, it verifies the info. Like for example, the customer ID, or if the customer ID is not available from the current session, it is going to trigger a human input asking the human, okay, please enter your customer ID or your identifier so that we can fetch the customer ID for you. And then after that, once the customer ID is validated, it loads the memory preferences of the customer. And then based on the user's query that has come in, it triggers the supervisor agent. I don't call it an agent, I call it a router. We call the supervisor. And the supervisor decides, in order to answer this question, which sub agent should I trigger? And it triggers the corresponding sub agent. And during this process, if required, it creates or it updates the memory as well. And once the sub agent is triggered, the sub agent performs the action and then gives back the response, and the process ends. So this is how it works. So the sub-agent, why we create multiple agents is because we want to ensure that things are modularized. Or in other words, we want to ensure that, what do you say? Um, Different agents have access to their own tools rather than one agent having access to the whole system prompt and the whole set of tools. Because if you do that, there is a higher chance for an incorrect output. There is a higher chance for the LLM triggering an incorrect tool. There is a higher chance for some aspects of the system prompt. System prompt is a set of instructions on how to behave. So there is a higher chance for the system, some aspects of the system prompt to be not followed. So you don't want any of it, which is why we ensure that we have a multi-agent system. And then the identity flow. So we talked about the user in providing the identifier as the input, email ID, phone number, etc. And then based on that, it looks up the DB, identifies what customer is this, and then it uses the rest of the databases as well in order to extract the invoice and whatever else. And for anti-hallucination, we talked about tool-only responses. That means do not come up with answers which are not there in the database, which were not provided by the tools. That is the expectation for anti-hallucination. And also, we talked about we talked about something like enforcing the scope. We talked about uh, giving exact codes rather than anything by the LLM directly by focusing on whatever the tool provided back to you. So all of these anti-hallucination methods also will be discussed in detail today. Don't worry about that. So coming to the graph compilation. So in the graph compilation aspect, we want to talk about what the compile function does. We want to talk about what the compile function does. Yeah. So we did talk about what the state graph is. So when you write a state graph in LangGraph, and when you call the compile function, what actually happens? So let's think of it like a recipe becoming a factory. So a recipe says, in order to bake a cake, mix the flour and the eggs. And if the dough is too wet, add more flour, then go ahead with the baking, etc. That is the description that we have. And the factory is the actual assembly that is going to execute this recipe repeatedly, handling any errors, handling any issues within it, tracking the current progress, which is the state, and also allowing us to pause this step in between and also resume whenever we want. And that is exactly what compile helps us with. So compile converts the graph description that we have into a runnable execution engine. We generally call it a Pregel execution engine. These are like a bit complex terms, but I just wanted to give you these names because if you're interested in knowing about this, you can read about this as well. So to understand that, Pregel is like a Google algorithm for parallel graph processing, and LangGraph is aware of it. LangGraph is capable of implementing this. So whenever the compile is triggered, what happens is, um, what happens is the graph description is going to be converted into a Pregel execution engine so that LangGraph can execute it. Now, in our system, we have three separate graphs in order to be compiled. One graph is the music state graph. And the music state graph is our hand-built React loop. So we talked about the reasoning plus action, and this hand-built React loop is the music state graph. And then the next one, the invoice React agent. And this was using the pre-built LangChain function that we just spoke about 5 minutes back, which was the create underscore React underscore agent, that function. And then the third graph that is to be compiled is supervised. So it orchestrates both of these. Supervisor orchestrates the one and two. So these are the three separate graphs that get compiled when the dot compile takes place. So the music state graph, the invoice agent, the supervisor. And the moment it performs dot compile, these graphs get compiled and these compiled independently. And after the independent compilation, the supervisor is added as a single node inside the multi-agent graph. And this is something that we call as the nested graph compilation. So this is what I was referring to. The supervisor here is added as a single node inside the multi-agent graph. So I don't want to complicate things right now. So superficially, I just want to tell you that uh, there are three graphs for you, and the dot compile function ensures that all of the three graphs are compiled. That's it. And this is how state graph is handled inside LangChain. No, the interesting thing is all of these three, they share one memory saver, which is a checkpoint, and also one in-memory store. We had actually discussed both of these yesterday. So I'm talking about the memory saver here, which is a checkpointer, and the checkpointer is going to say save the current state or the current delta. And then you have the in-memory store, and the in-memory store is going to save the preferences of the customer. So both of these, there is one shared memory saver as well as in-memory store for all these three graphs. So I just wanted to mention this graph aspect. If the graph aspect is confusing you, it's fine. Your understanding can be limited to yesterday's music subagent, invoice subagent, and the supervisor. That idea is more than sufficient. And this was just to help you introduce into the line graph aspects. Okay. Now, with respect to the conditional edges. So yeah, here, the conditional edges act like your security gates. So, see, the routing logic as to which node in LangGraph, LangGraph is a graph architecture. So, which node in LangGraph should run next? That is not decided by LLM, but rather that is decided by the Python functions that we have. Now, we have two conditional edges here. And the conditional edges that we have is the React loop control, which you can see in the graph, which you can see here, the React loop control, and also the security gate. First, the React loop control. So the idea of React loop control is, if you remember what the music assistant was, one moment, that was discussed yesterday, music assistant. Yeah, this one. So the music assistant had the LLM with the tools, and that decided which one to trigger. And the music tool node was what triggered the required tool. Now, this was the music assistant. Yeah. Do we have a detailed explanation of that here? No, this one. So, this was music assistant. So, after the music assistant runs, coming back to this, there is a function that checks, does the AI message returned by the music assistant has tool calls? If there are tool calls, then go to the music tool node. I did mention that the music tool node is what executes the tools that the LLM said that these are to be executed. The music assistant is the trigger to the LLM, asking the LLM what is to be done. If the LLM says these tools are to be triggered, the trigger goes to the music tool node. If the LLM says that no, we don't need any tools, then it does not, it exits this loop. So the React loop control, which is the gate one, controls on triggering the tools corresponding to the music assistant. Now the second one, the security gate. So after your verify information runs, the verify information is about validating whether the customer ID is logged in. Now after the verify information runs, there is a function that checks, did we find a customer ID or did we validate a customer ID? If yes, then we can proceed to loading the memory or the preferences of that customer. If no, and if the customer ID is not identified for some reason, then we want a human input. And that human input is triggered. And if you remember, at that time, the interrupt gets triggered. Interrupt means the whole system freezes or the whole state freezes and it waits for the human's input. Now, this is the security gate. And without the security gate, the problem is that uh, we will be able to mitigate any customer ID requirements so that I can pick your invoices, you can pick my invoices. There is no sense of privacy after that. So the security gate is imperative to ensure that it validates the correct customer before it fetches customer specific information. Now, yeah, we just talked about the security gate. And one moment. Right. So I just wanted to check something. Yeah, here. This should interrupt function here within the nodes.py shows us this. So if customer ID, if it is able to get the customer ID, then it can load. Wait, should interrupt function. Uh, wait, this is a bit encapsulated. I'm actually looking for something slightly different. Mm, wait, hold on. Yeah. Let me check if that's available here. Yeah, this one. This should interrupt function, the same one that I was showing you here. So this should interrupt function. Where exactly did it go? Yeah. So the should interrupt function is what decides when to interrupt and when to continue. If customer ID is available, it can continue. If the customer ID is not available, then it is going to trigger an interrupt. And when the interrupt is triggered, that is when the human is mandated to input something in order to break the interrupt. And that expected input is either the email ID, phone number, or the customer ID. So I just wanted to show that here. That's it. Now, this is a structural security gates that I wanted to convey. Now, with respect to the create supervisor, so the create supervisor, the supervisor library, this is a multi-agent routing, all of it into one function call. So if yesterday, as per the discussion, we had the different subagents. So you can see here that you have the create supervisor function, which is already from the LangGraph supervisor. So we are not writing our own function, but rather we are passing the correct parameters to the function. So the create supervisor is called, and we are saying that these are the subagents. The first subagent being the invoice information subagent, and the second subagent being the music catalog subagent. Now, we are saying that let's output the last AI message only, and we are saying that this is the LLM that we have. The LLM, we would have already initialized it earlier. And then we are saying that the corresponding prompt to the supervisor is a supervisor prompt. And then we have the state also provided to it. So if you remember what was the supervisor prompt? Supervisor prompt. Yeah. If you remember the supervisor prompt, this was it. So it explicitly says that if there are any off-topic questions, respond directly with rejection. If there are mixed queries, then call the invoice information subagent first, and then the music catalog subagent. And never add any information that is not in the subagent responses. So the third line prevents or attempts to prevent hallucination. And the second line is how to handle ambiguity. And the first line is what if off-topic questions come. And why did we not say if the question is about music, trigger the music agent, or if the question is about invoice, trigger the invoice agent? That is because for the music catalog subagent and for the invoice information subagent, you have the description corresponding to it already given to those subagents, so that we don't have to repeat those information or those descriptions of the subagents again in the prompt given to the supervisor. So this is an example of system prompt. And the system prompt given to the supervisor is called the supervisor prompt. And a system prompt means us or the developers giving a set of instructions to the agent or the LLM as to how to behave, how not to behave, etc., how to handle different scenarios, all of this. Now, this was the create supervisor internals. Now, with respect to tool calling, a step-by-step flow. So, inside the music React loop, this is what happens step by step. So first, see, in order to trace what exactly happens inside the memory when a user asks, what rock albums do you have? So think of these messages like your WhatsApp group chat, for instance. Now, every participant, like for example, the system, the user, the AI, the tools, etc., is going to post messages into it, into this WhatsApp group. Now, the LLM reads the entire chat history in the WhatsApp group and then decides what to do next. So, this is what happens on a very high level. Now, here, let's see. The first one being the system message. The system messages the music assistant rules plus the customer preferences that are injected into it. So what was the question that was asked? What are the grounding rules that was there in the system prompt? What is the expectation out of the customer? What is the expectation by the customer? All of this in the system message. Now, after that, parallelly, it also attempts to verify the customer ID using the verify info node that we talked about yesterday as well as today earlier. Now, then comes to the human message. And the idea of human message is simple: whatever the user asked, which is from the user via the add messages function. So, what was exactly the ask of the user? Now, the next thing is the AI message. AI message is what the LLM decided, which is to trigger the tool get songs by genre. And in order to trigger that tool, it has to pass an argument or multiple parameters to that function, depending on the function. So this function has only one argument, which is rock. Now, the LLM decided what tool to call, and that was the AI message. And the next one is the tool message. The idea of tool message is that this was what this was what the AI model used to trigger the tool. So after triggering the tool, what did the tool respond with? And this was the response of the tool. Track ID 1, song name is Breaking the Law, and the artist name is Judas Priest. So this was what the tool message returned back. And then finally, after taking a look at the tool message, the LLM decides no more tool calls are required. We have adequate information. Now let's create the response. So if you remember, this is exactly your reasoning plus action. So the reasoning was done by the LLM after looking at the human preferences, the human's question, the system message, all of it. And then the LLM decided that, okay, let me trigger this tool. And in order to trigger this tool, this is how I will structure the input into the tool. Now, the tool was executed, and after the tool was executed, the tool gave back the output. The output came back to the LLM, and the LLM they took a look at the output, and the LLM figured out whether further action is required or can it call it a day. And that is exactly what this message by message flow is about. So, uh, in this particular step, the LLM can also decide, okay, I do not have all the required information. Let me also trigger one more tool to handle this. So the LLM will continue this process until it has adequate information to respond to the query. How does the LLM decide whether it has adequate information? Because that's a large language model. It understands in order to answer the question, do I have all the prerequisites? If no, it will attempt to look at the tools as to which tool can be triggered in order to get this information. And as to the information as to which tool has to be triggered, when you define a tool, you will provide the description of the tool, like we saw yesterday. Once again, I can show you that. Where was that? Mm, mm, mm. Yeah, this one, for instance. So this is a tool which is marked by the tool decorator. And this is the name of the tool, Get Albums by Artist. And this tool requires one parameter input, which is the artist name. Now, this is the description of the tool mentioned in the doc string, which is the comment here. So this is the detail of the tool, and this highlights what the tool is capable of. So this is it is imperative that you add this properly so that the LLM can understand what this tool is capable of. If you mess it up, then the LLM's response is also going to be wild, because the LLM might call some other tool because the LLM doesn't know that this tool is capable of doing this because we did not explicitly mention this properly using the doc string. So this is how a tool is structured. In fact, tool looks like a regular Python function. And you're absolutely right about that. It's a regular Python function. Just that we use the tool decorator to tell LangChain that, yeah, this is the tool. So use it whenever required. And we are saying that this is the name of the tool, which is a function name. We are saying that this is the set of parameters that the function requires to take in order to implement. And this is the detail of what the function is capable of doing. All right. So that was about the message flow. Now coming to the next part, which is the database interaction deep dive. So in order to talk about the database interaction, you need to have some idea about, oh, sorry, this one didn't move. You need to have some idea about SQL. So in SQL, there is something called join. So why we use join is because this was how our data set looked like. Where is it? This one. So if you need information about an artist for some reason, also if you need information about the artist of a particular track. So the user asks the information about the artist of a particular track. So Based on the track name, this one was triggered. And then the track name is fetched. Okay, the track name is matched. And then we identify that, okay, this is the track. But do we have information about the artist here? Not yet. Because then it'll have to go to the album ID. And then based on the album, it'll have to go to the album database. Then fetch the artist ID and then come back to the artist table and then fetch the name of the artist. So it has to traverse through multiple tables. But instead of that, what we have done is a join function. The idea of join is that if you have different databases, you can join them into a single database based on your criteria. There are multiple joins like inner join, left join, outer join, etc. Depending on our scenario that we have. If it is inner join, you can perceive it as the intersection between two tables. So there are two tables, and if you want to join both of them together based on a certain column, then for that column, only those rows which are the same for both of them will be retained in the final joined output. So that is inner join. Now, left join means if you want to join two tables based on a certain column. Now, your first table has 20 values for the column. Your second table has 5 values for that column. And these 20 and the 5 are different. In that case, when you do a left join, the one on the left, which is the one on the first data frame, the values of the rows of the first data frame will be retained. And it will attempt to merge in such a way that only those values that are there in the first data frame is given importance. And if there are values that are there in the first data frame but not there in the second data frame, it will be there in the output of left join. But if there are some elements that are there in the second data frame, not there in the first data frame, they are excluded in the left join. There is also something called right join. There is also something called outer join, etc. Outer join is like the union. Inner join is like the intersection. Then there is left join and right join, which are partial intersections depending on whether you prefer the first data frame or the second data frame. When I talk about data frame, I'm actually just talking about the database that you have here. So internally, it is actually performing inner join or left joining depending on scenarios, and it is already given into the code. Now, okay, I just wanted to mention that aspect of the join. Then there is something called the dual key security. The idea of dual key security is that any query about the invoice requires two things. One, which invoice are you talking about? Invoice ID. But more than that, you require the customer ID as well. Because you and me might have the same invoice ID, or that invoice ID that I'm giving might be your invoice, not mine. So it needs to be validated with the customer ID as well, which is why the dual key security means you're not just looking at the invoice ID, because giving just the invoice ID is not going to get you the invoice unless you validate yourself by giving the customer ID. So invoice ID and customer ID is used in order to ensure that there is additional security and nobody can just fetch another person's invoice. Now, this is done once again using SQL. By the way, it is done using a query that looks like something like, yeah, I'll just write it here. So select, which is your SQL query, by the way, select star from uh, track. Wait one moment. Yeah, select star from track where name equals whatever. I just call it user input. Okay. This is a way to mention. Okay, sorry. This is a way to mention that whatever I'm writing here is a variable. That is why it's in the curly brackets. So if you write this, what is the problem? Anybody can pick anyone's invoice. So this is problematic. This is a problem. And in order to mitigate this, how we refine this is that instead of keeping it like this, we make a change saying that select start from track where name is equal to, instead of user input, we will say name is equal to name is equal to, we would give a parameterized value for name here. And what happens here is this is yesterday we discussed the same thing. This is SQL Alchemy's text function with named parameter. We call this as a named parameter that treats this input as a pure data, not as a string. Why? Because you want to prevent any SQL injections. We call it SQL injections because if you just replace this, if you just use the variable here, that variable could be another SQL command. So if people are smart, or if the hackers are smart, they could just send such SQL commands as user input in an attempt to jeopardize your whole SQL underneath. So, which is why you are attempting to keep this as a named parameter rather than trying to fix or trying to use whatever the user is providing directly into the SQL query. So we want to prevent any SQL injections that way. I'm just giving you a high level idea. Yesterday we discussed this anyway. Okay. Now, with respect to accuracy and validation. So if you want to ensure that your model or your agentic system meets the required accuracy, then first thing you got to ensure is you have a structured output. So whenever we talk about a structured output, an unstructured output means your LLM just gives a free flowing text as the output. But the problem with the free flowing text is that many a times there could be issues with formatting, issues with grammar, issues with the way the text is provided, etc., and also prone to hallucinations. So, in order to mitigate all of this, what we do is we will ensure that the output should be given following certain schema, like for example, a particular JSON format. So, we will give the particular JSON format ourselves, not the user, but in the backend, we'll give it ourselves and we'll tell the LLM that, okay, rather than providing a free flowing text, focus on filling this JSON or focus on filling the values of this JSON. So this is what we are doing in order to get a structured output. And in order to support us with this, we actually use Pydantic. So Pydantic is a Python package that we usually use for validation. It could be data quality validation, it could be the data format validation, anything. So it's a validation Python library, which using which we can set a defined schema. We can say that this is the JSON that we are expecting as the output. And then the LLM is going to fill the answers or fill the responses in that JSON. So this is what we'll be doing to ensure that there is a structured output. All right. So we call this a Pydantic schema, and we call this as Pydantic validation. Okay, one moment. Okay, one moment. Yeah, here. I was just looking for this example. So for instance, in the verify info node that we have here, and in the verify info node, we are mandating that when the user says my customer ID is 5, can you help? That is a free form user text. And we are asking the LLM to create a structured output in such a way that it has to fill this identifier equal to what. And the logic that happens here is slightly different because many times the user input may not be customer ID. User input can be email ID, user input can be phone number, etc. Now, the logic here ensures that the LLM picks up the email ID or the phone number or the customer ID, and then it triggers another function within it, which validates whether it's an email or a phone number or a customer ID. And if it is an email or a phone number, it cleans up that email. That means converts everything to lowercase and removes the spaces at the start and the end. And if it is a phone number, it ensures that the phone number is converted to a general format that we expect. And then it looks up the table in order to fetch the corresponding customer ID. And that customer ID is brought back and then populated in this schema. So these many things work underneath this. I just wanted to give you a high level perspective. And then similarly, you have the create memory node. And in the create memory node, the moment the person says something like, I love rock music, or I love rock and AC/DC is great, then we have to update the memory or the preference. So what happens here is that the LLM understands this and then fills the schema once again defined by us. And the schema was for the customer ID should be given, and then the preferences would be given as a list. More preferences that are being added, the list increases in size. So why we use Pydantic is because Pydantic library ensures that the schema is validated before the code ever touches the data. So if the validation fails, then this is going to go again, and the LLM is trying to fix this, understanding that the previous output had some issues with respect to validation and fix this. And now there is a higher chance that the LLM will give a correct answer because it was explicitly said that the LLM's response was wrong. All right. So this is how we get the structured output. Okay. Now coming to the validation layers. So when we talk about validation layers, I would like to talk about safety or security. So we have multiple locks or multiple validation layers here enforcing security. And we'll talk about what they are and where they are. So the first one takes us to safe underscore int. And the idea of the safe underscore int, it is a tool level validation layer. And what this does is it converts the IDs to integer, or it triggers a value error before hitting any SQL query. So in other words, it simply ensures that whatever customer ID it fetches, it is not a string and it is an integer. It's integer customer ID. Okay. Now, all the numeric IDs, it is not just customer ID, any numeric IDs like track number, invoice number, etc., whichever requires numeric values, we are just using the function save int to ensure that it's numeric. And this is on a tool level. Whichever tool requires input in the format of or output in the format of integer, this ensures that that happens. And the next one is parameterized SQL. And the idea of parameterized SQL is that, see, what we are not convert string into SQL queries. So that is exactly what the parameterized SQL ensures that is done. Because otherwise, if the string is directly concatenated, I did tell you that there are chances that your system can be accessed by malicious people with malicious intent. So you should not directly implement a string inside SQL because you don't know what that string is about. So you need to ensure that if it is a customer ID, that customer ID should be fetched from the session. If it is a user name, that username should be fetched from the session once again, rather than from whatever the what do you say, whatever the customer has provided. Now, the next one being empty result handling. So the idea of empty result handling is that, see, whenever there are no results from a tool, for instance, so you try to trigger a tool and the trigger says that there is no, the tool says that there is no information with respect to what you are searching. So by default, it is going to return an empty list. But the problem with this empty list returning is that it is not a string. And this can cause errors or this can cause issues in multiple downstream tasks. So instead of empty string, we'll be replacing it with not found, which is a string. So all of this looks very simple. Yes, they're very simple, but they are very important because when you build the entire system, things like this could be the reason for the failure of your entire agentic system. Now, the structured LLM output, we already discussed that using pydantic schema, which we discussed in the previous slide. So pydantic schema. And then there are some prompt grounding rules. Like, for example, we have some explicit rules telling that it should provide responses only which the tool provided it, and it should not hallucinate anything. Then it it has given strict instructions saying that it should quote exactly what the tool provided and not make any changes to it. Now, some honest failures. The idea is that, see, when some failure happens, it has to reattempt this and it has to log all of this properly. And scope enforcement meaning you should ensure that if you're talking about one customer ID, the scope remains limited to that customer ID, and any other customer's information should not be fetched. And now the graph structural gates, we don't have to do this. This is generally your Python conditionals. Like, for example, ensuring that there is no prompt injection, that is overriding a Python conditional. That means, see, prompt injection means people with malicious attempts in intent can be attempting to unearth your backend database data. So you have to prevent prompt injections, and that is also handled pretty well by LangGraph. So these are the defense layers or the security layers that we have. Now, the state management. So I was talking about all of this until now. I hope you are understanding whatever I am referring to. In fact, these are actually quite simple mechanisms that we incorporate in agentic systems to ensure that we have the safety, security, consistency, grounding, etc. Now, coming to state management. So I did tell that there is a whiteboard. And in this whiteboard, any changes to the entire system, any updations to the state, everything is added to this whiteboard. And we'll be talking about that. So the first one being add messages. The idea of add messages is actually very simple. We had actually talked about it earlier. So when the user gives an additional preference that they have, like the user has some additional preference. Earlier it was rock songs, now it's pop songs, etc. It should actually trigger the add messages reducer, and the add messages reducer adds the new preference of the user into it. So this is what happens. So here, see, with add messages, the state messages will be appended. So let me just zoom in a bit. The state messages will be appended with the new values. And without add messages, the problem is without it will be replacing the previous. Oh, by the way, the slide quality is fine, but the moment I uploaded it to this, the quality reduced. This one. Yeah. So with add messages on the right side, you can see that we have created an appended result. And without that, it ended up replacing the previous preference. And we don't want that. All right. Okay. So I just wanted to mention that aspect. So um, the idea is that when a node in the line graph returns new messages, don't replace the list, just append the list. That is the idea here. So which is why we were saying that it is more like a whiteboard. So um, anytime we have a new preference, we are going to add it to the whiteboard, and we are not going to erase the whiteboard and then write it again, but rather it's a big whiteboard where continuous additions are being made. All right. And one more thing. So whenever there is an updation, the updation ensures that it returns only the delta. So this is what we generally call as partial state updates. So when there is an updation or when there is a change to the messages, for instance, only that updated value or only that delta value is being returned. So that if we attempt to return everything, the problem is we have to fetch whatever there was before, and then we have to add this, and then we have to return it. Many a times, if the list has grown quite large, then this would be a bad idea. So, which is why we only give the partial state updates. That means what is the difference, what is the delta, or what is the new thing that's coming in, and that would be sent so that it can be appended elsewhere. So, this is known as the partial state updates. And then the message deduplication. So, the idea of add messages. Um, See, there is a message ID for each message. The add messages function, same message is added twice for some reason. Okay, if the same message is added twice. For example, you attempted to retry because it failed at some point. You attempted a retry automatically, and at that time, the message was already added. So if the same message is attempting to be added again, then this is mitigated, or that extra addition will not take place, and that is the message deduplication aspect that we were referring to. All right. So I just wanted to touch base on the add messages reducer. We actually talked about this yesterday as well, but maybe not as much as in detail. And then the next step is to prevent infinite loops. See, uh, this is yet another production safety mechanism where you have to ensure that nothing happens in an infinite loop. So, uh, for example, I did talk about the function here earlier, should interrupt, right? Instead of that, there is a function called should continue. And the should continue function is going to tell us that if there is any update, this should continue the process and it should not be terminated. So even if the LLM is done, for some reason, it still triggers continue, continue, continue. Then what happens is without a safety net, your agent will keep calling tools forever. And what happens? Your LLM's tokens will keep burning and your API credits will be exhausted. So you have to prevent infinite loops. Now, there is something in LangGraph called the remaining steps. So there is something in LangGraph called the remaining steps. And by default, the remaining steps is equal to 25. And this is your kill switch. So what happens is every time a node is executed, the remaining steps reduce. So every time a node is executed, verify, it reduces to 24. Memory, it reduces to 23. Supervisor, it reduces to 22, so on and so forth. And that means that in case the reasoning plus action loop is stuck, and keeps looping again and again for some reason, then the should continue is going to trigger again and again. And then the remaining steps will be your safety mechanism. So the LLM keeps calling the same tool. The results are misinterpreted again and again, continues being triggered. Now, the remaining steps into the picture. And then LangGraph reduces or decreases this automatically, right? And the moment when it reaches zero, an error will be raised saying that we have reached the maximum remaining steps. In this instance, an error is better than your API being burnt continuously. Error better than exhausting your API credits, because we would be using LLMs like OpenAI, for instance. LLMs like GPT-5, for instance, and you have fixed credit, or you don't want a lot of credit burning, exhausting your API credits, exhausting your LLM API credits. So, just wanted to mention this aspect. So, this is the regular mechanism that we can do with an error. But in our implementation, we are not using an error, but rather we are mitigating this with a function. Where exactly is that function? One moment. Oh, wait. Remaining steps. I was actually looking for a function. Wait, we can find it. I was actually looking for a function. One moment, I'll just write it. So the idea is that in the state, we have the remaining steps. So what we'll do is, uh, without throwing an error, we can gracefully exit by simply returning an empty placeholder. Like for example, if state of the remaining steps is equal to 1 or something like that, then we can return an empty dictionary and we can call it a day. So we are ensuring that the memory creation, the repeated memory creation is mitigated. That's it. So the logic is that the remaining steps keeps decrementing whenever it performs the loops again and again. And that means by the time it reaches zero, it is going to throw an error, ensuring that it does not burn your API credits infinitely. Okay, so this concludes our infinite loops part. Then coming to logging and observability scenario. So we just crossed 1 hour. So let's continue. Okay, 1 hour, 15 minutes. All right. So the logging strategy. So why should we log? The thing is, see, if we do not use logging, we won't be able to debug anything. We won't be able to understand what happened under the hood. We won't be able to understand whether it can be optimized. Nothing. So which is why logging is crucial. And I don't need to explain it to you because almost most of you would be software engineers who have better idea about logging than me. So the logging strategy that we are going to follow is simple, that every significant event gets a log entry along with the context. So this is what we are doing. For instance, every tool call, uh, every error, every tool result, etc., is going to be logged along with the context. So here, one moment. In the instance of verify info, let's take a look at this for explanation. So our logging strategy is such that we log the timestamp, we'll log the module name, we'll log the level, and we'll log the message corresponding to it. Now, here, you can see that the verify info node, when it is triggered, we will ensure that it is logged that we call the info. And then the customer verified is the customer ID number 5. Similarly, load memory is triggered. And then the logging is in such a way that we will say that the memory loaded for customer 5 is rock and ACDC. Once again, it's info. And then the tool called, this time the tool that is called is get albums by artist, and we are passing the artist as ACDC. And the tool result, after calling the tool, we get the result. And it says the tool result is get albums by artist, and the result length is 245. And then for some reason, if it throws a connection error or timeout or something like that, that error is also logged, saying that this is not an information, but this is an error. And the error is in this function, and the error was connection timeout. So your usual logging pattern. So, all right, just wanted to mention how the logging is done. So all of the modules that we have here uses the logging. So generally, you are already aware of this, most probably, at least for people who use Python, we use the logging package. And in the logging package, we have the get logger. And this is what we usually use for logging. Now, inside the log, you can filter by different functions that you have. You can filter by the different tools that you have. You can filter by the different kinds of logs, like whether it's an information log, whether it's an error log, etc. So you can log it properly so that it can be retrieved for any debugging purposes, any fixing purposes, any optimization purposes, and all of it. Now, yeah, right. So this was the logging that I mentioned earlier. Now, in a production grade system, if you're actually going to a production grade system, there are some additional consideration with respect to logging that would be great if you can inculcate this. The first one being correlation IDs. The idea of correlation ID is that so you will be generating a unique ID per request, and you will be passing it through every log message. Now, when a user reports something like, say, something went wrong at 3 p.m., then you grep for this correlation ID, for their correlation ID, and then you see the entire journey across this correlation ID. So this issue that happened at 3 p.m. was for this particular user. So you pick the user ID, the UID corresponding to that session, and then you identify the entire flow by filtering it using that UID so that it'll be easier to debug because there'll be multiple users, multiple instances happening parallelly. So you want to ensure that different sessions are segregated so that you can pick the logs depending on the sessions. And the next one, in Langsmith, we have something called tracing. The idea of Langsmith tracing is that it gives you a visual trace of every LLM call that you're doing. So in the LLM call, what tools were called, what was the input, what was the output, what was the token usage, all of this information can be traced by using Langsmith. By the way, this is not LangChain, this is not LangGraph, this is Langsmith. And some of you might be knowledgeable about it, that Langsmith is used for ensuring that how much tokens are being burned, how much, what is the input past, what is the output past, and all of it. In fact, you can say that it is used for observability to ensure that we are observing. Uh, this is a framework provided by the LangChain creators in order to perform observability. There is also something called LangFuse. If you want, you can take a look at it. By the way, LangFuse, even though the name starts with Lang, it is not created by the LangChain creators. Just giving you a heads up. And Langsmith is very easy to integrate with um, LangChain based setup or LangChain based agents. Now, you can also consider using other metrics, like, for example, the tool success rate. So this is a metric that you can possibly use in order to identify how many instances of the tool calls gave an error. And also, there is a health checkpoint that you can see whether the database is active or if the database is facing an issue. Only if the database is active, you will be able to be able to run this agentic system, right? And then you also have latency metrics that you can use. And for that, you can consider exporting it to Prometheus or Grafana in order to create fancy dashboards if you want. Now, Prometheus can help you fetch the LLM called latency, DB query time, total request time, etc., which can be created into a dashboard by using Grafana. So there are multiple tools that you use for observability like Langsmith, Langfuse, Prometheus, Grafana, Evidently, etc. Just wanted to mention those. Now, that was observability. Then we are going to section 6. Just let me ask a question to the host. So, what time have we planned a break? Is it after a particular section number, or shall I go ahead? How is it?
How long will this session take, Justin?
We have almost covered midway.
Okay. So, then maybe let's take a break right now. I will
Okay.
step in.
Or is a break planned for a particular time or
So
something?
we
Let me
generally
just check
plan it
that.
around 1:30 so that the first part, so generally we have two sessions, right?
Mm,
So
mm.
the first full session gets over around 1:30 and then 10-15 minutes in between to talk about IK offerings, and then we talk about the topics in session 2.
Okay. So yeah,
So
currently it
if you
is
feel
like
currently you are
1:20.
exactly in the midway, we can take a
Mm.
break as well as I can answer some questions about
Yeah, it's
IK.
more or less at the midway. Let's go ahead with that then. Yeah.
Awesome. Okay. Uh, thanks, Justin. It's been a very engaging session till now. I can see that even Abhinav has been busy answering most of the questions. So, guys, I'm going to take a few minutes here because generally, when we do these sessions, they are particularly focused on some topics on agentic AI or generative AI. And many of our audience members also want to know that if there is a structured approach to upskilling, especially for your own tech domain. Is there a way to do that? So you can, I'm going to just share my screen if somebody can confirm if they can see my screen. That would be great in the chat. You guys can see my screen? Yes, okay. I've started. Yes, visible. Cool. So I'm going to play a short video by our co-founder Ryan, and he's going to talk to you something which is very, very relatable, right? Like all of the the AI influx that has been going on in the tech industry. What is happening? Who all are getting impacted? How is it changing jobs across, not just in India, but across the globe? And what can be a possible way forward? So have a look at this video. It's a 3-4 minute video, but most of what he says will be very, very relatable.
AI is no longer the future. It is here.
You can hear it. Just a yes, one yes would be helpful. Whatever I played, yes. Okay, awesome. Thanks, Madhu.
It is the now, and it is the skill that every single person in technology needs to be on top of if you want to survive and also thrive in the next many, many, many years. This AI wave has unlocked unprecedented opportunities for all of us. If you look at all the hiring over the last few quarters, you see that all the growth has really come in AI roles and now increasingly so in AI-enabled roles. Far more importantly, the compensation that we are seeing here, going up to $1 billion in some cases, is unheralded. It's unprecedented and nothing that we've ever seen before. We ourselves at Interview Kickstart are constantly seeing our own alumni who are AI-enabled or have AI and ML skills getting offers, and in many cases are $300,000 to $400,000 more than their peers simply because they have the AI skill set. The challenge, though, is that AI is moving at warp speed. It's moving so fast that it's very difficult to figure out both where to start and how to pick a path that is customized, or to use a word often used these days, fine-tuned for you. That's where we at Interview Kickstart come in. We have built a career acceleration platform that helps you turbocharge your career with AI skills. We've been doing this over the last 12 years, and I've already worked with over 25,000 working professionals from all domains in tech: software, product, data, ICs, managers, and the entire like. Our approach is unique. We believe that the frontier of AI has moved to the world's best companies and the world's best AI labs, which is why we bring together a platform of over 700 instructors, all of whom come from the likes of Google, OpenAI, Meta, Anthropic, and other cutting-edge AI companies. Everything that we bring to you is designed, developed, and delivered live by these professionals. And so they bring their frontier lived experience to every single classroom. We also believe that the world has changed. It has moved from an era of passive learning to now active building. And so in each of our programs, you will get your hands dirty. You will build AI projects all oriented on helping you build an AI portfolio, because that is what is required today if you want to turbocharge your career. Finally, we realize that there is no one size fits all in AI, and AI really needs to meet you where you are at. And all of us are at different levels, have different experience, have different backgrounds. And so we offer a plethora of courses that is completely flexible. They range from 3 months, 6 months, 9 months, 12 months, spend more than a year as well, based on your career goal. They're fine-tuned for every domain. We have 18 to 20 domains that we cover. We have separate courses for ICs, separate courses for managers, and we have versions in pro code, low code, and no code. Bottom line, we want to meet you where you are and work with you step by step as you up level to building a fabulous AI career.
Yes. So, like Ryan very rightly said, a lot of tech professionals, and because we customize it for so many of them, about 18 of them, we tend to talk to people from different tech capabilities, different career stages. You can be an IC, you can be a people manager, you can be an EM, for example, and leading a whole engineering team. Uh, a lot of people don't know where to start, right? Even if you're, for example, watching a YouTube video, you don't know, is this the start of, is it teaching me a concept, a tool, or is it actually helping me build an AI path? Because most of the enterprises, so 2025 was more tool oriented, or it was you sort of understand one particular concept and you kind of try to use that in a POC or something. But it's more about 2026 and beyond is more about how you're going to use that as an AI native system for big companies, right? For companies that you work in or you are trying to target. So that changes the ball game a lot, right? And for that, most of the people, what we have understood from by talking to many of learners like you, that they want something more structured. They want to know, okay, this is where I started. This is how it impacts my job. This is start. It's not a start from scratch. It is actually building on the tech stack I already knew, and I've worked for about 10 years, 12 years, because generally our typical learners are between 8 to 20 years of experience, right? So most of them are senior folks. So you might be facing some of these four things that are written in front of you, that you're not able to do AI. While I think most of you who are here in this session don't have that denial that I don't want to do it because it's moving too fast. You're making an effort. So that's step number one. There's too much out there. So this is something that I spoke about, that you don't know whether is this a start, is this the middle, or is this the end? What are things changing? How do I keep track? Right. So there's so much of information. Sometimes it's also a deluge of information which you cannot maybe manage and apply in your job. So some people also say that my job is way too unique to be impacted by AI. But I think we are past that stage, tech, non-tech across, right? And some people feel that no, do I have to start from scratch? Will I have to down level? Do I have to get demoted to sort of start or join the AI bandwagon? None of that is applicable. So if typically we have to see the graph of how AI has taken over our lives and our work lives and personal lives. So we essentially in 2022, when it all started, or 21, it was more about more productivity focus, your own personal productivity, right? So we had LLMs, we still have LLMs, but so you had your co-pilots. So these helped you augment your work that you were doing, right? But now eventually, and this year it's particularly going to be about transformation using AI and enabling yourself with AI to transform the tech stack that you have. So either it could be by what Justin is teaching you, right? Agentic AI. Or you, so if you want to get into, if I move on to the next slide, if you're targeting roles where my cursor is, which is you want to stay in your domain, but you want to become AI enabled, right? So that is one path that you can go forward. That I want to be a software engineer, but I want to be an AI enabled software engineer or an AI enabled product manager. What does that mean? So due to the interest of time, I wouldn't be able to spell it out for 18 different domains that we train you for, but I can get you in touch with one of our program advisors. I'm going to share a link in the chat after I finish. The second path is if you want to get into very AI intensive roles or ML roles, if you want to target, right? So you become AI enabled, you build those skills up on top of it, or you want to sort of transition into ML roles or AI intensive roles, right? So that's the other part. So for all three, we have one or the other program that may be applicable to you and it'll be helpful for you. First is, I'll talk about the middle one first, which is the Transformative Gen AI and Interview Lab. So it's about 14 weeks of AI upskilling. Uh, like I was talking about, making you an AI enabled, whatever your domain is, AI enabled software engineer, AI enabled TPM, right? And then because we are also outcome focused, and this is not something that is provided in India at this point of time, about 18 tracks for interview preparation in your domain. So while you will learn the skills of AI, but how do you actually present that in the interview? How do you talk about it? How do you crack those interviews? Because, and we are talking about interviews for MANG level companies, MANG plus level companies, right? So not just your Meta, Amazon, Apple, Google, Netflix, but also Microsoft, Atlassian, even Zomato, Swiggy, Razorpay, all of the Indian startups which are doing so pretty well. How do you target those companies? And those interviews are not getting easier, right? There's a way, there's a structure to sort of crack them. So the second is if you have an understanding of programming languages pretty strongly, and you are somewhere in the middle of AI journey. So you have some understanding of, say, what a RAG is, or what a land graph is, like Justin was talking about, and you just want to build an agentic AI portfolio, which you can then show to an interviewer or your manager to get that next jump. That is what something the agentic AI accelerator plus interview lab does for you. And that is delivered with the PwC India team. So it's co-certified also by the PwC India team. So we work on some 4 capstones over there, which are industry specific, and you can build a portfolio. Again, interview preparation is present over there also. So about 12 weeks of agentic AI up leveling, and then about 3 to 4 months of interview preparation, similar to transformative Gen AI and interview lab. The third is if you want to get into that, if you tell me, hey, Niyati, I want to get into completely ML roles, then we have flagship ML and interview lab. We start from classical ML, go to deep ML. You do not need prior experience in ML for this. Okay, we start from scratch over here. Then we also touch upon generative and AI and agentic AI, do capstones. All of the programs that you see in front of you in the green boxes, by the way, they are all project oriented. Okay, so what do I mean by that? That no concept is just theoretically taught. You actually pick up a small project. In the end, you also have capstones, which are much larger and more portfolio ready, but you touch upon most of the concepts using case studies or assignments or projects, okay? So that you know what you're talking about. It's just not theory. Uh, if on the left hand side here, you'll see start here if you're unsure. So if you are not sure what you want to do right now, the best way to start is Transformative Gen AI and Interview Lab, because this is something that's going to be table stakes. You have to become AI enabled in whatever tech domain you are, right? So on the right, you'll have the duration also mentioned, which is 3 + 3 months, about 6 to 8 months is what typically take. There's also self-paced content, little bit of it, which is part of it. The first one is the Agentic AI Accelerator Interview Lab that I spoke to you about, that we deliver with PwC India. The duration is written over here. And the third is the flagship MLR Interview Lab. Flagship ML and Interview Lab also contains Gen AI and agentic AI concepts. Okay, so if you want to transition, if you're an SWE, want to become an MLE, this is the program for you. We have specializations of MLOps, so a lot of SRE folks come and take up this project also if they're looking for that transition. This is about a 10-month program. This is the pricing that you can see in front of you. There's a range that is written because of the domains. It depends on the domain that you come from. So there's customization given accordingly. Okay, so talk to your program manager. I'm going to give you the link of booking a calendar as per your convenience with one of our program advisors, a program leads actually, Atif, and he'll be able to guide you properly with his team to answer all of the questions that you have. All of these come with EMI options. We have loan partners. We also have a 50% return clause that Atif and his team can tell you more about. Currently, we have some offers going on. And so let us know if you want more details. I'm going to launch a poll right after I'm going to stop sharing, and to understand whether you want a personalized consultation or not. Okay, so now coming to the interview lab part or interview preparation part that I was talking about, there's AI up leveling, and this is the second part with all the programs that it comes is the interview preparation. So there are about 18 domains, like I said, we deliver. Some of them are, four of them are missing over here because they have been consolidated into some of them. But in total, 18 of them. And we also uh, we tend to understand if you are, say, a 5 to 8 years of experience person or somebody with 15 years of experience person. We try to first understand where you are in your career, what your target goal or company or salary is, and then only tell you what is the right path for you, right? So we don't do one size fits all. We don't do a straight jacketed approach. That is not what IK does. In the interview preparation part, first we'll cover, for most of the domains it is common, but for some of the domains like a product manager or TPM, it would differ, right? Because over there we follow like a no code, low code sort of approach. So DSA and system design is anyway covered in the interview prep because that is the base of your interviews that you do. Then, for example, for EMs, we do a special leadership round prep. And then for example, for front end versus a TPM, your domain based interview modules will be very different. Topics in the interviews that they ask will be different. The other services, for example, working on your resume, working on your LinkedIn profile, uh, we give about 15 mock interviews with people like Justin across all of the three programs. Okay. So you're doing 1 hour mock interviews with people of that experience and getting very direct feedback and verbal detailed feedback of what you can improve, what you can do, etc. Right? Then salary negotiation, behavioral coaching, all of that is provided. We have about a network about 200 hiring partners in India, and we keep, depending on how you're progressing in the program, we keep sharing your profile with our hiring partners also, right? So about 250 profiles in a quarter are shared depending on the demand also from our hiring partners. Yeah. So over to you, Justin. You want to take forward the rest of the presentation. I will,
Yeah.
for everyone's benefit, I'm going to do a couple of things. Like I said, I'm going to launch a poll. Let us know if you want a personalized consultation regarding our structured programs. I'm also going to post the link of booking a meeting with Atif so that you can, directly talk to him. And yeah, over to Justin. Thank you so much for listening.
So, hello everybody, welcome back. So, we were talking about the error handling deep dive. So, this is where we stopped. So, let's get started with that. Right. So, the idea of an error handling is, like most of you know, that a well-designed system is going to fail gracefully, and we have to ensure that the user does not see the Python traceback error that comes up. So these are the things that we are going to do in order to ensure that there is a graceful exit. Now, the first one, the safe underscore int guard. So we already talked about that. So we are here to ensure that this is run before the SQL query. So if someone passes someone passes ABC for track ID should be a number. Now, that is rejected cleanly with a message saying that uh, this doesn't look like a valid track ID. So that is the safe integer guard. So that's a very simple mechanism that we use to ensure that um, the non-numeric values do not go into the SQL query. Now, the next one is the try catch block. So the try except block. So the idea of try except block is very simple. We are going to use it in every tool. So we have a total of 9 tools, or in other words, 9 functions, where the first agent, the music agent, uses 5 tools. The invoice agent uses 4 tools. So we have try except blocks in every tool. And the idea is that you try or you attempt to do something. And if that attempt fails, then the exception is triggered. And rather than seeing the error string, it is going to see uh, a friendly string saying that, okay, this did not work as expected. Can you try again, or something like that? Okay, it is going to see a helpful string rather than an error message. And this is the reason as to why we always use try except in production grade system. Now, which you might already be aware of. And in the UI, you have something that can help, which is the in UI, we have something that can help, which is the generate response. The idea is that, see, um, if there are some unexpected slips through the tool level guards that we have some additional guards in the UI that catches these and then shows a graceful message. So we have exception handling in the UI as well. So in case for some reason there are some values that slipped through the tools, then the UI is going to catch it and the UI is going to ensure that it gracefully exits. And also you have DB health. So whenever we start up the system, when the application starts up, the database health is verified or the database accessibility is ensured, so that the Chinook database, which we talked about, the Chinook database, if it is not accessible for some reason, then it'll throw a graceful exit saying that this database is currently not available and can you retry later or something like that. So these are the 4 error handling mechanisms that we incorporate. In fact, most of them are just try catch or try except, and we also have some identic schema which ensures certain schema output. We also have some ensuring the expected data type, like for example integer. So these are the error handling patterns that we are using. Now let's just skip to section 7 because these Niyati already covered it for you. Now coming to section 7, which is the production grade engineering. So the idea is that, see, in production grade engineering, we'll show you what the system currently has, and we'll also show you what would be good to have. To make a good production grade system, what would be good to have? And out of these, what do we currently have? Starting with parameterized SQL. So we already told that we have parameterized SQL to ensure that the text injection or the string injection does not happen into the SQL commands. Because if there is a string injection, there is a chance that somebody could extract your entire database or somebody could fetch your entire database by using SQL injections. So, which is why we use a parameterized. So that is all. And the next, so at this, the code base, you can see that, wait, .env. Yeah. So you can see that there is a file called .env.example, and you are expected to copy this file as another .env file where you will give your secrets. Like for example, the OpenAI, the OpenAI secret key. So here we are copying the env example file into a file called .env. Why does it start with dot? Is because it's a secret file. So, so this secret file consists of your OpenAI API key, where you can add the OpenAI API key into it. So this is why we call it an env-driven config. So your OpenAI API key is inside the .env file, and it is never hard coded. It is never hard coded into your production code. So if you commit, so for example, if you decide to use GitHub, and within GitHub, you have the provision to add this secret into GitHub. Similarly, when you deploy it in Hugging Face spaces, within Hugging Face spaces, one moment. Within the Hugging Face spaces, you have the provision to add secrets as well. One moment. Yeah, I just stop this. Yeah, the access tokens. One moment. Yeah. So you can see here that the access tokens can be provided like this, or the secrets can also be provided in the same way without the secrets being explicitly visible to the end users. So this is what we will be doing in Hugging Face spaces. Similarly, in GitHub repo. So in our GitHub repo also, we have a provision to add secrets, by the way. I just forgot where exactly it was located, but it probably in settings. Yeah, here, secrets and variables. And here you can click on the GitHub actions and you can add the corresponding secrets like the AWS account ID, AWS role, etc. So similarly, in your code base itself, we are providing the env files, which are the secret files that we have. And then for structured logging, we did mention how the logging was taken care for the tool calls, errors, the different actions, everything logged with proper context. And then we also have a set of tests. So we have automated test cases. We have 28 test cases, which you can try running the test cases using PyTest, by the way. Here, this executes all the 28 test cases that you have in order to check whether your system is working properly as per the test cases that we have developed. So the test cases are also taken care of. Then the support for Docker. So we have Docker file that we have provided. If you want to Dockerize this entire system to containerize and then deploy, you can also use Docker support. That is also taken care of. Then the input validation. So we already talked about ensuring that we have integer values for certain variables, ensuring that the LLM's output is in a structured format, ensuring that our phone numbers are normalized. All of this is the input validation. And then what is good to have? What would make it an even better production grade system is persistence. So I did talk to you about the two kinds of memory that is good to have. One is the ephemeral memory, which is the short-lived memory, which we will have the context of the current session. So that is the in-memory store. And then you can have a long-term memory, which stores the preferences of the user. Now, the catch here is that currently we have the in-memory store and the memory saver. But the limitation is that the moment you restart your entire application, these gets wiped. So there is no concept of persistent memory. So when you restart your application, still the memory should be there. That is why you need to have persistent memory. So generally in production grade system for persistent memory, we generally use something like Redis or PostgreSQL to ensure that there is persistent memory, which we do not have here. Now, the retry logic. So the idea of the retry logic is simple. There is an error that OpenAI API returns. Like for example, the error 429. The error 429 simply focuses on, I'm just taking an example, it simply focuses on a rate limiter. So the idea of this is that whenever you see error 429 from the OpenAI API key, the gist is that you are hitting an API limit, not the API limit, but rather you are hitting that rate limit. That is the correct way. So you are hitting the rate limit. So when you hit the rate limit, the idea is that, see, OpenAI within itself would have a rate limit saying that if your code is running too fast, throwing a lot of requests, then OpenAI servers are going to block it. And that is your 429 error, which means too many requests in very little time. Now, generally, how does your code mitigate this? Your code would attempt to retry. You attempt to retry again and again. So if your rate limit is at 500, then you do 500 requests per minute and it is going to throw the error 429. Now, in order to mitigate it, your mitigation strategy would be try running the code again. And that makes it 501. And when you have 501, 502, etc., that is not going to mitigate your rate limit issue because the limit was 500 and you breached it. Now, the strategy in order to mitigate this is called exponential backoff. The idea of exponential backoff is very simple. If one attempt fails, wait 1 second and retry. If 2 attempts fails, wait 2 seconds and retry. If 3 attempts fail, wait 4 seconds and retry. Exponential. 1 second to 2 seconds to 4 seconds to 8 seconds, so on and so forth. So this is how exponential backoff, the mathematical strategy of exponential backoff works. So I just want to give you my 2 cents on this. We use a Python function called tenacity. We use a Python function called tenacity in order to mitigate this. In tenacity, there is a function called tenacity.sleep, which we usually use to implement exponential backoff. So I'm just adding the terms here. Exponential backoff. These are good design considerations, by the way, in order to mitigate issues like rate limiting. All right. So, that is mentioned here, rate limiting. Yeah. So rate limiting and retry are heavily, combined, which is why I just talked about it in the same way. And then we already talked about persistence, right? Because we want a persistent database for this purpose. And then the CI/CD pipeline. So something like GitHub Actions. The idea of CI/CD pipelines mean in your production grade system, if somebody makes a change to it, like one of our developers make a change to it, and the moment a code change comes into play, it should undergo a set of test cases which you have already created. And once the test cases have been passed, then it should go ahead and deploy this new code. And that is the continuous integration and continuous deployment. Continuous integration means it performs the checks in the test cases when a new code comes into the picture. And after that, it creates the Docker file, and then it productionizes the Docker file by pushing into Kubernetes or wherever you are deploying. So that is the CI/CD pipeline. And one example of this is the GitHub Actions. So I did open a repo here, right? So in this repo, this is a totally different repo, by the way. I just wanted to show you GitHub Actions. So in this pipeline, you can see that I had tried pushing code multiple times, and many of the code pushes through an error, some error or the other. And then after that, I pushed a different code change, and this time it passed all the test cases. And once the test cases were passed, it performed the deployment as well automatically. So that is automatic deployment after performing the automatic checks. That is CI/CD for you. And then we do not have monitoring as well. It would be good to have. We already discussed Prometheus, Grafana, evidently all of this which you can use for monitoring purposes. All right. So, okay. And now coming to performance and scalability aspect. So we did talk about persistent storage already, so I'm not going into the details of that once again. So it would be good to have a persistent Redis storage for storing the preferences, for instance, which we do not have. Currently, what we have is an ephemeral storage mechanism. So it would be better to have proper dedicated memory, like for example, PostgreSQL or Redis for storing all this. Now coming to the performance and scalability aspect. See, right now, our system is capable of handling one user at a time. Let's think about what would happen if it changes to 1,000 users or 10,000 users. At that time, you will be facing issues with respect to performance as well as scalability. Now, the first problem is that we have synchronous LLM calls. And when we have synchronous LLM calls, this is going to block the server. So when we call functions like llm.invoke, right? llm.invoke. And llm.invoke, we will invoke it with the messages. And what happens here is the Python thread that runs this waits for OpenAI to respond. Maybe 2 seconds, maybe 3 seconds, maybe 5 seconds. And during the wait, the server cannot handle any other request. And that is why asynchronous calls are the answer to this, is the solution to this. So what we generally use is, in order to mitigate this, what we generally use is something called async chat OpenAI in order to implement asynchronous requests. And also we use await. So Python's async IO module handles the input output concurrently while waiting for OpenAI to respond to user number 1. it serves user number B. Same thread, but multiple users. Now, the second problem is one DB connection at a time. So currently we are using something called a static pool. One moment. Yeah. Currently we are using something called a static pool. And the static pool focuses on a single SQLite connection. One SQLite connection. And the problem with this is when you have multiple concurrent queries coming into SQL, there is a pileup. So instead of using static pool, if we use queue pool, then you will be able to mitigate this issue and you will be able to introduce concurrent DB queries instead of one after the other. Now, the third issue that you will be facing is repeated identical queries. So, which requires caching. So the idea is if some user or people continuously ask for, based on the current trend or whatever, people are continuously asking for one particular rock band or something like that, the details of one particular rock band or something like that. Or there would be continuous questions like what genres do you have, or what rock artists do you have, all of this. If there are questions that are repeatedly asked again and again by different users, then it means that why don't we store the response to this in a cache, so that when a user asks something related or relevant or very similar to this, we can just pull up the answer and give it to them, rather than triggering the LLM going through the whole agentic loop. And that is what cache is about. So generally, we perform caching using something like Redis, and we use a 5-minute TTL for this. So your first query hits the database. Second, or the next 499 queries, if there are 500 queries, the first query hits the database. The next 499 queries are going to hit the cache, not the database. So there are multiple mechanisms of caching in LLMs. One is called the most frequent queries caching, which we'll just discuss now. There is also one more method of caching called the key value caching. I'm not going to discuss about that, but there are multiple caching strategies within LLMs and agentic systems that you can try reading about. Now, the next problem that we are going to have is expensive tokens. That means, see, we are currently using an expensive model like your GPT-4o. Now, when you use GPT-4o everywhere, you know that GPT-4o is more expensive than some other model like GPT-4o mini. So you have the GPT-4o, which is more expensive than GPT-4o mini. It is more expensive and also the performance will also be better. But do you always need this better reasoning performance every single time? No, you don't, because GPT-4o is more expensive. And it's, if I remember right, it's like 5 or 6 times more expensive than the GPT-4o mini. So for simple tasks like classify this query as invoice or music, or extract the preferences from this conversation, in such scenarios, your GPT-4o mini is more than sufficient. Now, which is why we introduce model tiering. That means you use the expensive models only for complex scenarios. You use the less expensive models for the regular scenarios. That is the idea of model tiering. So you reserve the expensive models only for complex multi-step reasoning tasks. So this is about model tiering. And then you have the horizontal scaling. The idea about horizontal scaling is that, see, every app instance, if you make it stateless, and all the states are going to even external stores, then you will be capable of adding more instances very easily. So that is the concept of horizontal scaling. And if you can incorporate horizontal scaling, and in order to incorporate horizontal scaling, we use something called Landgraf's. So no, in order to improve horizontal scaling, what we do is, like I said, we make every instance stateless, and every state we ensure that it lives in external stores, so that you can add more and more states to it, and just that you can add more and more instances to it, and the states can be stored in the external stores that you require. So this is an example of horizontal scaling, which is also not implemented here, which could be great in order to improve the whole setup. Okay, just wanted to cover a few aspects. And also, rather than going through each queries one after the other, if you decide to batch it, and if you run batch queries, then it would be better than sequential tool calls wherever it is possible. So this is the batching the database queries as well. All right. So these are some design considerations which you can use to improve it or make it more capable for production systems. All right. Yeah, this was the horizontal scaling that I was referring to. So the idea of horizontal scaling is that, see, we discussed earlier that see, currently, wait, in order to introduce horizontal scaling, we need to first make your individual app instances stateless. And then the persistent state persistent state for the apps will be stored in external stores. And hence, horizontal scaling can be achieved easily. Now, on the other hand, here, one moment. Currently, we are using an in-memory SQLite. So if you remember, we are loading the entire database into memory currently. So the problem with this is that it will prevent any capability of scaling because you're loading everything into memory. And instead, if you replace it with some kind of persistent file system, then multiple instances will be able to handle this memory, this database effectively. So your in-memory SQL will be faster, but from a scaling perspective, it is not worth it. Just wanted to highlight this aspect. And now coming to the professional engineering decisions, and with the idea is why each architectural choice was made. So with respect to the architectural choices that we have, why did we go for the hand-built music React? Because if you remember, in one of them, which is the music agent, we used our own React, hand-built React. And the second one, invoice one, we decided to use the pre-built React. So why did we go for the hand-built React here? So there are two reasons. One, your create React agent function, which is the pre-built React agent functionality. If we use this, the problem is that you can't modify the internal routing logic. And if you build it manually, then you can control every aspect of it. Now, the second reason is that when you build it ourselves, when you build it yourself, you can add any custom logic inside the loop that you want. Like, for example, checking the remaining steps. So you can add whatever custom logic that you want if you decide to use your own React agent or your own React setup. Now, why did we go for GPT-4 or Mini? And also, why did we go for temperature 0? The idea of temperature is whenever you run a LLM, you can give it required temperature. The higher the temperature means, the more creative the model is going to be, the less deterministic the model is going to be. And the lower the temperature, the more deterministic or the higher the chances that the model is going to give a same or similar output. Now that is temperature equal to 0. Now, when temperature is equal to 0, your cost is, when temperature is equal to 0, you will get more deterministic outputs. And if you have deterministic outputs, that is more better for a customer service system rather than a very creative output. Creative outputs are required for something like, uh, creative outputs are usually useful for something like email generation, text generation, image generation, etc. But our case is purely customer service. We have to have it grounded to the data that we are providing. So deterministic outputs are better for that. And also, if you are using GPT-4 or Mini instead of GPT-4, the cost is also very less. Now, why did we go for in-memory SQLite instead of a real database for the demo? The reason is zero architectural dependency. Now, anyone can clone the repo. You can run the repo. You can set it up without setting up the DB. And which is why we focused on in-memory SQLite. And the next, and that is not a good design consideration when you think about scalability. But for building a basic multi-agent system, this is very helpful and this reduces a lot of dependencies. Now, why did we inject customer ID as a system message instead of a human message? So the idea is that why did we use customer ID from the system rather than letting the human provide that as an input in the text? The problem is that we are the reason is that we are providing the system role a higher authority than the user role in OpenAI message hierarchy. And the downstream agents are going to treat system messages as the ground truth. And if you put customer ID in a human message, the problem is that the LLMs may decide to ignore the customer ID because it was a human message. But system messages, there is much lesser chances of the system messages being ignored, which is why the customer ID was kept as a system message. Now, why did we go for? So, yeah. So here, the create verify info node, which takes in the LLM as an input. It makes the nodes unit testable. Each node can be tested separately. So in the tests that you do, you can pass the mock LLM instead of the real one, so that for testing purposes, you will be able to run everything smoothly without any issues because you want to test the individual nodes separately. Now, why did we go for Gradeo instead of something like Fast API plus React? Fast API exposes the endpoint and React builds the UI where it takes the endpoint and then exposes it, shows it to the user. So we decided to use Gradeo instead of that because we want to make it simpler. We want to make the UI in such a way that we could just spin it up in a few lines of code. So it is more in chat UI. And also another reason is if you want to deploy it in Hugging Face spaces, when you build a new space in Hugging Face, it asks, what is the UI based off? If you give Gradeo, the chances of you facing an issue or an error will be much lesser and you will be able to tread smoothly. Just wanted to mention all of this. Okay. One moment. Give me a moment. All right. So when coming to the real product, what changes would you possibly make? So we discussed multiple changes that would be a great addition to the real project. Like for example, the data layer. Why not use a PostgreSQL instead of in-memory SQLite? Now, use Redis for preference store. And we also discussed include database migration techniques and connection pooling. So these are good considerations that you can build for the data layer when it comes to a real product. Similarly, for an agent layer, if you use Langsmith, you can observe how the performance is. And if you decide to use asynchronous agents, then it is going to ensure that it can handle concurrent requests. And if you cache the results of tools or if you cache the results of LLM calls based on the queries that are frequently being asked, then that can also be really helpful in speeding up the entire process. Now, from a safety layer, you can include PII masking. PII masking means something like personal data names, and all of this can be masked, and this can be an additional security layer. Now, you can have rate limiting per customer ID and not just per session. So that every customer ID can have limited you have rate limits to use this. So for example, if they're automating the runs, so you can ensure that it does not burn your LLM's credits significantly. Now, for an infrastructure perspective, for CI/CD, you can use GitHub Actions. For auto scaling, horizontal pod auto scaling, you can use Kubernetes. Kubernetes will be like your manager for the multiple containers that you have. Then you can consider using Prometheus and Grafana for observability purposes to ensure that it identifies the metrics and Grafana populates it into a fancy UI with all of the required dashboards that you have. Not UI, dashboards. Then you can have structured JSON logs, ensuring that rather than just simple string-based logging, you can use JSON logs as well, so that the logs can be persisted in proper structure. So these are some considerations that you can use in order to build a real product with more capabilities, which we'll be covering in the IK sessions, by the way, in detail. Now coming into the next part, which is the advanced deep dive into the code and the roadmap. Now, coming to the create memory function. The create memory function is actually the most complex node that we have. The idea is that we will trace the create memory node step by step. And this does 5 operations in sequence. So let's just go to that graph. Right. Yeah, here, this one. All right. The first thing is we load existing preferences from the memory store. So it is something like we load the rock, jazz, etc., which are the existing preferences. And the next one is we build the context from the last 10 messages. So this prevents a token explosion, because if you decide to use the last 100 messages or something, it could cause a lot of tokens or a lot of words being used to trigger the LLM, and that will burn your token usage a lot. So the next set is to extract the new preferences via LLM. So depending on what the user has provided, we need to extract the new preferences. And the LLM looks at that and then extract the preferences, because there is a system prompt saying that extract preferences from this text message to the LLM. And the LLM understands that, okay, the new preference is AC/DC. Now, the next one. If the new preference is empty for some reason, okay, we don't have a new preference, or the user did not provide a new preference for some reason. And if it is empty and alt preferences exist, then what you can do is you can skip writing. That means you will be preserving the previous preferences. Now, the next scenario is if it is not empty. That means if we identified new preferences, then it should be appended with the old preferences and it should be saved, or your preferences should be updated. So the idea is that never delete previous preferences. So that is the concept in the create memory node. So why this is important is because, for instance, earlier we had rock and jazz. For some reason, the user did not provide a new preference, and the new preference will be extracted as an empty list. So we want to ensure that that empty list does not replace the list consisting of rock and jazz. So which is why this is identified as an empty response, and then you will completely skip any kind of writing if the output is an empty response. All right, just wanted to cover this aspect. Now, one moment. So moment. So for identity lookup, we already discussed yesterday that we have three strategies. Strategy number one is when the user gives email as an input. Strategy number two is when the user gives phone number as an input. And strategy number three is when the user gives actual customer ID as an input. So you can see here that the identifier is arriving from the user into the verify info function. And inside that, the first thing is we have to check whether it's an email. In order to check whether it's an email, we use a methodology as to whether it consists of an @ symbol. If yes, we convert the entire email to lowercase, and then we search it in the TB and fetch the corresponding customer ID based on the email. Second strategy, is it based fully with, is it completely comprising of digits? If yes, try to assign it as a temporary customer ID and then try to check if the DB has that customer ID. Strategy three, if it's a phone number, then, for example, if it has 5+ digits, then normalize the phone number to the standard format that we have, and then do the same search in the vector DB, in the DB, in order to fetch the corresponding customer ID. And if none of these are found for any of these, then once again, the human input node is triggered. So this is the verify info, which is a 3-strategy lookup logic in order to identify what the customer ID is. Now, you have the supervisor prompt. So the idea of supervisor prompt is that, see, it's a decision tree. And this decision tree has multiple rules where every rule has a specific purpose. And the first thing is, yeah, we'll discuss this. So, the quality degradation is massive. Here. Okay, coming to the supervisor prompt. So initially we get the customer query and the supervisor LLM. And based on the customer query and the supervisor LLM, along with the routing rules. So yesterday we had discussed the routing rules, if I remember right. Routing rules. We had it somewhere yesterday. I remember that clearly. We had the routing strategy. We had everything written in proper. Not here. Where was that? Yeah, this one. So for every be it supervisor, be it a tool, be it anything, we have multiple mechanisms incorporated here, saying that this is your role. And these are the grounding rules. These are the tools available. These are the search guidelines. And these are the user preferences, etc. Similarly, in this particular scenario for supervisor, what you have is certain routing rules. And the idea of routing rules is that based on whatever is coming in, you need to decide what to call. For example, the first routing rule is if the query is about a music, then call the music catalog sub-agent. If the query is about invoice, then call the invoice information sub-agent. And if the query is mixed in nature, like for example, someone asks, um, um, which which artists' songs have I ordered the most? Then in that case, it needs to fetch the invoices first, and then fetch the albums in the invoice, and then go to the albums and find out the artists corresponding to it. So that's a mixed query. And then you have an off-topic query, something like, how do I cook a steak? So that's an off-topic query. In such a scenario, it should be a direct rejection saying that this is not a question pertinent to our customer service chatbot. So these are the routing rules. Now, you also have the response rules saying how to combine all the answers into one response. And so you have to combine the answers into one single response, and do not drop the answer of any subagent, and never add any information that the subagent did not provide you. So these are rules that help in grounding the supervisor, ensuring that the output is consistent with whatever the user is anticipating. So, yep. Though I just wanted to mention how the supervisor prompt is working and the working strategy underneath it. All right. Now, these walks us through the different concepts that we use within the multi-agent system orchestration, and also some design considerations as to what can take this to the next level of a production system. So that is what we talked about until now. Now we are going into a future roadmap. Now, the next thing. So we discussed multiple aspects that we can incorporate as the next best thing, but which ones should we start with? And this is the roadmap as to in what direction you can go ahead. The most important would be persistent storage. And something with higher priority would be streaming responses for token level streaming in order to improve the perceived latency. Now, the rate limiting. So the idea of perceived latency is that, see, you ask a question to ChatGPT. Do you have to wait until ChatGPT finalizes the answer and gives you the answer in one go? No. But rather, ChatGPT behaves like it is providing one token at a time to you. And you're seeing the tokens in front of you, right? So this reduces the perceived latency. And that is what is meant by token level streaming. So the next one is rate limiting. So the idea of rate limiting is that you need to prevent a customer abusing the system if the rate limit is more than what you're anticipating. And the next one would be playlist tools. So playlist tools is something like, see, we have a playlist track table, which consists of 8,715 rows. Now, if we can add tools for this table, which can browse curated playlists by genre or name, then that could also be helpful. So that is of medium priority. And then the CI/CD pipeline, I already mentioned what the CI/CD pipeline is. The idea of CI/CD pipeline is that continuous integration and continuous deployment. So when you make a change to the code base and push it, it should undergo the test cases. It should automatically containerize. It should deploy the container to production. That is CI/CD. And then structured JSON logging. Current logging is purely in the format of text or the string. You can change it to JSON logging in order for better debugging power. purposes. And multi-language support, the priority is very low. And also feedback collection from the user, thumbs up, thumbs down, just like how the chat GPT behaves. That is also priority low. So these are the things you can consider incorporating into making it better. All right. So this walks us through the entire details of the code repo that we had, including the internal workings of the different functions, of the different agents, of the different tools. All of this we discussed over the last 2 days. So I know that we have gone into some additional detail today, but I try to keep the detail as superficial as possible because I know that we have a diverse cohort here. So I'm trying to keep it as simple as possible in a way that all of you might be able to understand it. That is my expectation. I'm not saying that all of you understood it. So my expectation was that all of you might have understood that. All right. So yeah, we discussed the different aspects that we had to cover today, and that concludes it. By the way, I see there are questions coming up in the Q&A. So, and that are being answered live by Abhinav. Thank you very much, Abhinav, for taking this, because otherwise I wouldn't be able to answer this 100+ questions that are being asked. So thank you very much with respect to that. And there are some interview questions as well in the slide itself. So if you go through the interview prep, there are 3 questions, two or three hard questions, and which you can possibly attempt to answer in order to how to scale up the system or how to make this system more production grade and all of this. We can take a look at that as well. So how would you scale this to 10,000 concurrent users? We did discuss multiple aspects by which we can possibly do this. Now, the first one would be creating a stateless app layer. So we did talk about the fact that if we make the instances stateless, and then if we have the if we have the memory corresponding to that stored in a in a different storage, then you will be able to scale it much better. And also, you can add a horizontal scaling, because if you decide to containerize this and then use Kubernetes for this, horizontal scaling can be easily achieved in Kubernetes. And replacing the in-memory stores, by the way, these might be a bit advanced because these are system design in nature. If I have to explain all of this in complete detail, it's going to take me a lot of time. So which is why I'm trying to keep it superficial here. Now, they replace the in-memory stores. So this is what I just refer to. So instead of having the memory store loaded into your memory or your RAM, rather than that, have separate memory stores like Postgres Saver for conversation checkpoints, Redis for storing the long-term preferences, Persistent SQLite or PostgreSQL for storing the Chinook dataset, ensuring that it is available for all the instances. And then asynchronous execution. So we already discussed you can use async chat OpenAI plus async SQL Alchemy in order to utilize the Python's async IO. So the idea is that one worker can serve many concurrent LLM requests rather than waiting sequentially. Then optimizing the LLM calls. So caching the tool results for identical queries, which we already talked about earlier, and we can use Redis TTL for that. And then we discussed about having different tiers of models like GPT-4o mini for simple questions, GPT-4o for complex reasoning. And then observability. How can you make this? So in order for scaling, you need to ensure that there is proper observability. Otherwise, you will have no clue as to what went wrong and where. So for that, you will be using Prometheus for latency metrics, Langsmith for tracing your tool calls, correlation IDs before going into production to ensure that different sessions will be working parallelly and logs will be written for different sessions. So correlation, so this UIDs for the sessions will be what helps understand what logs are from which sessions. All right. So just wanted to mention the response of how to scale this for 10,000 users. Now, the next one is to design a logging and observability system for the multi-agent architecture. We already discussed that in multiple instances. So we have 3 pillars here. One is the logs as to what happened. One is the metrics as to how healthy the system is. And one is the traces as to what was the request flow. So the logging can be done using the logging function in Python, or you can even use a structured JSON logging, which we discussed. For metrics, you can use Prometheus, Grafana. You can even use LangSmith, it also gives some metrics. You can also use LangFuse. And for traces means to understand how your request flow took place over the complete setup, over the complete tools, over the complete agents, etc. And for that, it is recommended to use LangSmith. So these are the three aspects or the three major pillars of logging and observability for this use case. Now, the next one is, how does this system prevent prompt injection? Now, the idea of prompt injection is that we already told that if an attacker with a malicious intent embeds instructions in the user prompt in order to attempt to hijack the LLM behavior, it could be SQL queries embedded in the user prompt, it could be some other instructions embedded in the user prompt attempting to uncover the underlying personal data or something like that. So how do we mitigate this? The first one being, we use a system message for customer ID. So we verify the customer ID, and then once the customer ID is verified, we use the system message for the customer ID, and we do not let the user override it. The next one is a structured output. So whenever the LLM's output is being created, we force the LLM to return the output in a particular format, validated by agentic. So the structured output for extraction ensures that it does not, the user finds it very, the person finds it very hard to inject anything into it because we are creating a structured output from the LLM. Now, in the prompt, in every system prompt, we will have proper scope defined. So something like, do the things only pertinent to the scope of this tool to ensure that anything outside the scope of this tool is not handled here. So this is, you are modularizing the scope. And the next one is the graph structural gates. We already discussed this. So there is this should interrupt. So the idea of should interrupt is that it's a Python code, and the prompt injection will not be able to override this Python conditional. And the graph enforces the verification irrespective of the LLM that you're using. So should interrupt is a graph structural gate that provides additional safety to your lang chain. Sorry, your lang graph. Then the parameterized SQL. So we already told that a person should not be capable of injecting a SQL query in the format of a text into the agentic system, which is why we use a parameterized SQL. So there are parameters that are bound by name, where we use SQL Alchemy text, which is to prevent any DB layer injection. So all of these are aspects that we use to prevent any jailbreaks or injections into the system. So these are some interview questions that were covered, and we covered multiple aspects today. I know we covered a lot of things, starting from deep orchestration, talking about the compile, talking about the Pregel algorithm, talking about the create supervisor function, security gates, conditional edges, etc. We looked into the DB join. We looked into the dual key security aspect of DB. That is, we will be using the customer ID along with any other parameter that is to be fetched, so that there is a double layer security. And then we discussed order by discipline as well. What was order by discipline? So just like the join, we are ensuring that we have an order by function where we'll use that for data fetching. And then for accuracy. So we discussed, for ensuring proper validation, we have a structured output from the LLM, which is validated by agentic, and the function is called using API. And we have 6 validation layers that we discussed, and we also discussed the defense in depth. So for state management, we discussed the add messages function, how it works, and it is append and not overwrite. And then we also used remaining steps to ensure that it doesn't go into an infinite loop. That is the infinite loop prevention. And then we have partial state updates. That is, we update only the delta. We provide delta in order to perform the update and not the entire updated set. And for observability purposes, we talked about logging, we talked about session IDs, we talked about LangSmith for tracing, we talked about Prometheus for metrics, etc. And for error handling, we talked about try catch or try except. Then we talked about the safe integer guarding. We talked about the graceful degradation. And graceful degradation means, rather than throwing out exceptions with the error being shown to the end user, if we showcase only the only a graceful exit showing that we were unable to do it now, please try later, or something like that. And the typed exceptions, and also the agent never crashes. The retries is what we are talking about. Now, the production, how we can productionize it. So we can have persistent storage, we can have rate limiting, we can add more security, we can add, we can migrate our memory to Postgres plus Redis. All of this were what we discussed today. And for performance, asynchronous LLM calls, polling the different connections, caching the responses, streaming the tokens for a more or less real-time output, and then horizontal scaling using something like Kubernetes. All right. And we also saw some interview questions as to how to handle observability, prompt injection, how to scale it to thousands or 10,000s of users. And then we also saw some architectural decisions as to why we did that. So kindly extensively debug this, make changes to it, see what breaks, mitigate it. And this is the way that you learn. Try to add different aspects which are currently not yet added, which we discussed in today's session. Try to add all of them. Let's see how it improves, or let's see how it behaves. Because there might be some downsides, probably something like latency, or there might be some upsides, something like preventing any kind of security threat, preventing any kind of issues with the storage wiping off, etc. So you can try the different methods, you can attempt it, and you can see what works and what doesn't. So before, let me just share this one once again, because in case you joined a bit late. Yeah, let me just share it with you once more in the chat. So, yep. So that concludes the topics that I had to discuss today. Yep. Yes,
Yeah.
please.
Amazing, Justin, super time efficient. Thanks a ton for that. And I think, like you rightly said, Abhinav, thanks for pitching in and answering so many questions. So we still have about 15-20 minutes, which we can use to answer questions in case people want to put that in the Q&A section or in the chat right now. Both can be managed because we have concluded all the topics we wanted to cover. So if you have any overall questions, Justin has a very detailed experience in the kind of roles that you might be targeting. So if you have either questions on the topic that was taught today or the career path you should take to, become enabled with all the agentic AI skills that he touched upon, you can ask any questions. So we'll wait for a few minutes. I think Sheetal is asking for if architecture decision, if we can summarize once more. Yogesh,
Oh,
you're going to get the YouTube link of the session. These were live streamed, so the program advisor can share it with you. So don't worry about that. Yeah, I think architecture decision is something that was the core of this, Justin. I think a lot of questions were coming in.
yeah.
If you want to just touch upon it.
Okay.
Thanks.
So one moment, I'll explain the architecture decision. Before that, Harshil, you are asking, please explain agentic AI using MVP. Are you referring to MCP? Or are you referring to the minimum viable product, MVP? If you can clarify nowadays, I can go into the architectural aspect. So where exactly was the architectural aspect that we were talking about? So not this is logging and observability. One moment. Is this what you're referring to, or the current architecture, or are you referring to the potential future improvements when you asked about the architectural considerations? The high level architecture is very simple. You inject a query, sorry, you ask a query, and the query is taken up by the supervisor, and the supervisor, the LLM in the supervisor tries to understand what sub-agent is to be triggered. Whether this question is about music, whether the question is about invoice, whether the question is a mix of both, or whether the question is totally unrelated to our use case. If it is about music, it is going to trigger the music catalog sub-agent. If it is about the invoice query, it is going to trigger the invoice info sub-agent. And if it is a mixed query combining both, then first it is going to trigger the invoice subagent so that it can fetch information from the invoice. And then using that, it is going to trigger the. When I zoom in, suddenly the quality drops. And then the quality comes back. Then I zoom in, the quality goes great. Oh, no worries. Yeah, here.
It just takes a few seconds to render. That's all.
Is that so?
Yeah,
I
yeah.
mean, it was actually rendered and then it goes.
Right now it's legible. It's
Then
going
it
and
goes.
coming back. Yeah.
Is that so?
No, it's still not rendered. You're correct.
Yeah, no worries, no worries. It's fine. I can use the actual slides for this. So what I was saying is, once the customer's query comes in, the supervisor agent is responsible for understanding what this query is about. Now, I won't call it an agent, but rather I call this supervisor a router. So the supervisor decides to trigger the music catalog if the query is on music, the invoice info, if the query is about invoice, and if it is a combination of both, it first triggers the invoice subagent and then it triggers the music subagent using the information from the invoice subagent. And in the off case scenario that it's a totally different unrelated query, it is going to say that it is unrelated and I can't answer this. So these are the things that the supervisor is supposed to do. How does the supervisor do it? The supervisor does it easily by using the LLM that it has, the GPT-4o. But how does the GPT-4o know that these subagents are there? That is because in the supervisor, we explicitly say that these are what the supervisor is supposed to do in the system prompt. And also the supervisor has access to the description of the individual subagents that are there. So supervisor knows that there are these subagents and these subagents are capable of doing this, not by analyzing the code, but by the description of the individual subagents that we provided. Now, hence the supervisor now knows when to call the music catalog subagent and the invoice info subagent. The only thing that the supervisor would be confused about is, what about queries when there are mixed queries? What about instances when there are mixed queries? What about instances when there are unrelated queries? And that is where is it? Yesterday we had covered the. One moment. What was the name of that? It was something like supervisor query prompt. Yeah, this one here. See, it says the system prompt says that in the event that there are off-topic questions, respond directly with rejection. In the event there are mixed queries, then provide the trigger the invoice information subagent first, and then the music catalog subagent second. And then it also mandates never to add information that is not there in the subagent responses. That means, in other words, do not hallucinate. Now, that is the supervisor. Now, within the music catalog subagent, you have 5 tools. So yesterday we had discussed that music catalog subagent. This one, yeah. In the music catalog subagent, you have 5 roles, 5 tools. No worries. How do I? All right. So in the music catalog subagent, you have a reasoning plus action loop. And the reasoning plus action loop has a music assistant first. And this music assistant is going to decide what tool is to be triggered. And how do we decide what tool is to be triggered? It is because each tool has a function name. It's a function. They have a name, they have a description. The description of the tool is what the LLM understands in order to decide whether to call this tool or not. So to write a robust description for the tool is up to you. So you have to ensure that the tool's description is clear and the tool is properly demarcated from the other tools that we have. So, for example, you have one of the tools here. Do we have an example of that? We have an example of that. I'm trying to find it. Tool. Wait, I can just search for tool. This one, yeah, here. So you can see here that this is a tool, and that is shown explicitly by the tool decorator. And this is the name of the tool, and this is the description of the tool here. And if you add a more descriptive description of the tool, then the LLM will understand better as to what exactly this tool is doing. And then the LLM has access to the tools. And now the LLM knows what each tool is capable of doing. Based on that, it can decide what tool is to be triggered. And one more thing, every tool has an expected input. So it is on the LLM to produce the input parameter to the tool while calling the tool. So it has to provide this artist as a string, and the LLM is responsible for doing that when it decides to call this tool by the name get albums by artist. So supervisor, music subagent, invoice subagent, and these are the two subagents that are there. And then there is then the supervisor handles how to trigger all of this, and also whether to say that I don't have a response pertinent to you. All right. So this is how the overall workflow works. Okay. So Harshil, you are asking about MCP. So the idea about MCP is that MCP is a unified connector. So consider this. You have a few agents. Consider that you have 5 agents and you have 20 tools. And you want all of these 5 agents to be capable of accessing these 20 tools. Without MCP, the problem is you will have to write individual connectors for all of these connections. In total, you will have 5 into 20, 100 connectors, which you will have to write. Instead of that, you can come up with the concept of MCP, or you can use the concept of MCP in order to have the MCP client. And the MCP client is going to take the information from the host to the MCP server. MCP server resides with the tools. So you can create MCP servers for the different tools, and the MCP servers can be used to connect to the application. And the MCP client is what runs between the host, which is your LLM or your Claude, whatever you're using, and the MCP server of your application. So the MCP client runs between both of this. So you can integrate MCP as the connector. So usually in almost all of the teaching videos of MCP, what we learn is MCP is like the USB-C connector that you use to connect to your electronics. So before, you had different charging cables for the different appliances. Now, for the different electronics that you have, almost all of them have USB-C. So you just need to have one connector. So that is what MCP is about. Instead of having 5 into 20 connectors, in the example that I mentioned before, you just need to have a single connection, a single connector, which is your MCP. So MCP is like your HTTP that was used for web connections. But for agents, it is MCP. And if you want to know more about MCP, this is a website that contains the list of MCP servers. And if you want to integrate something like, for example, I want to integrate with my agentic application, I want to integrate a LinkedIn job search. Okay. Then how do I do it? How can I scrape LinkedIn? There would be some MCP server that someone has created for this. So LinkedIn job, let me just search. Yep. There is this LinkedIn jobs MCP server that someone has created, which you can use directly. If you want to use this in Claude application, you can just use this MCP server and directly connect it to Claude. Let I just share my complete screen so that you can get an understanding. So in Claude, so one moment. So here, by default, Claude is not capable of producing the transcription of a YouTube video. Because if I ask YouTube Claude to, you can see Claude, I suppose. When I ask Claude to transcribe the contents of the YouTube video by giving the link to it, it says that it cannot directly access YouTube videos or watch them. Instead, you can probably use these tools. But instead, there is an MCP server there is a tool that is capable of doing this, which is called Superdata. And Superdata is capable of accessing the YouTube videos, transcribing them, and all of these. Now, Superdata has an MCP server. So you can use Superdata's MCP server and create a connector with Claude. And you can see here there are connectors. So I had already created a connector for Superdata, and you can trigger this connector or you can turn on this connector. And then after turning on this connector, you can ask the question, transcribe the contents of this YouTube video, and then it will take a look at the connectors or the tools that it has access to, and it identified that it has access to super data, and then it produced me a transcription of the YouTube video. This is what I wanted. So it helps connect the host, which is my cloud, to the tool, which is super data, using MCP server of super data, where the host and the MCP server talks to each other using something called an MCP client in between. So I just wanted to give an example for this. That's all. All right. Yeah. Thanks, Abhinav. Abhinav was just posted in chat saying that popular MCP servers include those for SQL databases, GitHub, Google Drive, Slack, etc., for productivity integration. And these are available via open source repositories. And if I remember, I had seen Slack the other day. There was an MCP server for Slack here. Wait, maybe the name is slightly different. Yeah, this one, Slack. All right. So there are MCP servers available which you can connect it even to your cloud, for instance, and you don't even need to build your own agentic systems for that. Yeah.
Justin, you're sharing your
Yeah.
screen?
Not now.
Okay.
I was actually sorry about that. So what I was saying is I just searched for Slack and I found that there is an MCP server for Slack as well. I thought I was sharing my screen. I was earlier sharing my screen about the YouTube transcript, right?
Yes,
Were
yes,
you able to
we
see
saw
that?
that.
Okay,
We saw that only in this
perfect.
part.
Perfect. Now, what are the other questions? Let me just stop sharing temporarily. Okay. Can you provide Terraform or VPS setup scripts to set up this example? You mean? Are you referring to the code base that we shared? The thing is, I don't have the Terraform or VPS ones for you right now. So probably we can add it to the GitHub repo. What are the protocols supported in AI enabled systems? That is a very general question. So do you have anything particular in mind? Other than MCP, do you have anything particular in mind? Because when you ask what are the protocols supported in an AI enabled system, that's a very generic question. So it totally depends on your system that you're building. So MCP is optional. We won't be using it everywhere. So MCP is one example where which is a protocol that you would be using. And generally there would be like you would be definitely using REST, like HTTP, HTTPS. Like for example, if you want to integrate the systems with APIs, then you would be using the application layer, you would be using REST, and you would be using something like gRPC for remote procedure calls, and you can use WebSockets. In fact, see, MCPs, like I told you, then for robotics purposes, we actually use something like DDS, which is called Data Distribution Service, or MQTT, like the message queuing telemetry transport. So there are multiple protocols that you can use depending on what you want to build the system for. Right. So that's why I told it's a very generic question. Can you tell the process of adding a connector to Cloud? I'm trying, but it's not working. So each one has a different method to add. So for instance, if it is about super data, there is a set of instruction on how to do it for Claude. Yep. For setup instructions for Claude, see the integration guide. Okay. Yep. Here. So for different MCP servers, they would have a different set of steps on how to make this change. So usually what you do is there is a file in your system for Claude. I forgot the name of that file. One moment. I just fetch it. MC. Give me a moment. So it's called Claude desktop config.json. Give me a moment. trying to share my screen. So in your system, you would have something called Claude desktop config.json. Mm, yeah, this one, the Claude desktop config.json, which was inside library application support Claude desktop config.json. You can take it to any editor of your choice, and you should be editing it with the MCP server of your choice. So you can add MCP servers, and you can see here that why am I not able to zoom it? Yeah, perfect. So you can see here that I have given the command to use Superdata's MCP using npx, so which is a REST API. So uh, I forgot the exact thing for this name for this. It is REST. So these commands, I had actually followed it from Superdata's GitHub repo, and then I gave the Superdata API key, and that was good to go. All right. And similarly, if you want another application, this is how you can create it. So whatever is there inside this refers to each individual MCP server. There are two of them here, and you can see here in my Claude code, there are actually two of the connectors. See, which I have disabled temporarily. You can enable whenever you want it. So for that, your Superdata depends on your application. Some applications would require an API key. Superdata requires an API key. So which I actually took it from the Superdata website, and then I updated the cloud config.json, and it was good to go. All right. What else? Mm. Can you please give any other sample from scratch for beginners to practice? Are you referring to agentic AI, or are you referring to MCP? So Yogeshwar, you're asking agentic AI. So if you want a simple application from scratch, which is multi-agent in nature, I would recommend you to go for Crew AI. So when you go to Crew AI, in Crew AI is a framework that is very beginner friendly, which can be used to build multi-agent systems. So within their GitHub profile itself, you have multiple applications. Like for example, writing job descriptions, planning trips. Planning trips means creating the itinerary, booking the flights, booking the hotels, etc. Performing stock analysis, etc. Let me just share this with you. I've just typed the answer in the as a response for you. Let me just share it with everyone in the chat. So you can go here, and the interesting thing is the code is also available, and also there is a video explaining how it works. So this is very beginner friendly from my perspective. And Crew AI, like you asked, is relatively much more beginner friendly than compared to LangGraph and all of that. And if you want, you can also implement all of these in N8N. N8N is used to build no code agentic systems, and IK scores with respect to N8N, or IK scores covering N8N is quite comprehensive, I would say. So how can we build an application that is scalable for, I think I lost it, one moment, scalable for different models? Is it a good architecture to make the system from nimble with multiple subagents rather than a monolithic agent? Yes, it is. So it's actually a design consideration that you go for. So if your use case is not complex, one agent would suffice. But the complexity comes with tools. So if you feel that all of the tools are not required for all of the applications or all of the use cases, then it makes sense to separate it to subagents, because the more tools you have, there is a chance that your LLM will incorrectly pick a tool, right? So if you have different use cases, and if you want to separate them such that the first agent can use three tools, the second agent can use three tools or four tools, so that they don't have to reuse the tools that each of them has access, so that everyone doesn't need access to all of the tools. So this would make the system less erroneous or less prone to hallucinations, and that can really help the multi-agent system. All right. Okay. So Yeah, I hope I was able to provide answers
Yes.
for your queries. Yeah.
Yes, we don't have any open questions at the moment, guys. We are taking, I think, one last question. Uh, I have anyway also launched a poll that we generally do at the end of every session. It just helps us deliver better and better sessions in the future. So please share your feedback. Let us know if you want to talk to us about our programs, and also leave some comments in the feedback section. Or some suggestions if you have. We'll wait for another minute or so for any questions that might come up in the Q&A section. We have Justin for another last 3-4 minutes. Meanwhile, Justin, thanks for providing all of the material that you have. It's amazing how you do it month on month, this for us. So thanks again for that. And I already can see from the feedback that a lot of people have loved it in terms of the rating scale, as the rating scale says it. So yeah,
Thank you very much. It means a lot. Yeah.
yes,
And I know that today's session might have went a bit complex, but I felt that I should be doing justice to folks who actually are looking for a slightly complex deep dive into the architecture, which is why. So if you find today's session a bit complex, it's fine. Yesterday's session is actually more than sufficient to get started with the implementation and to understand what's happening. So don't
right.
worry about that. Yeah.
Right. I think we did that on purpose because in the past sessions there were audience members who wanted us to cover a little more advanced level also. So we did that rightfully. So Justin, so thanks for that. But of course, everything that Justin has covered here, see, in our programs, it takes many hours and weeks. We have to spread it out because we have to break it down into a lot of concepts here. Here we try to pack up as much as possible in the 3 hours that every day we have on yesterday and today. So keeping that in mind, I think we covered most of it.
Yeah. By the way, Niyati, there are some questions on certification.
Yes, so I have answered a few of them. Certification, we generally take a few days post the event gets over. But if you don't get it, you generally will get it on your email. If you don't get it, just ask your program advisor. He or she can provide easily. But wait, give us a few days. We typically take a few days to
Sure.
deliver.
Yeah, thank you very much for your comment, Pratyush. I saw that.
Yeah.
And Ratna Prakash, you have asked, can we integrate multiple MCP servers with an agent? Yes, you can. Because if you saw my Cloud, that itself has two MCP servers connected to it. You can actually enable both of them parallelly. See, you can enable both of them parallelly. And then, depending on the question, Cloud is going to figure out what to use. Okay. And there was a question in the chat about uh, about can you please send the integration MCP URL as well? Integration MCP URL. What exactly did you mean by that? Are you referring to the super data one, or are you referring to something else?
Madhukar, this is a question for you, which
If you
Justin.
can answer it, I can share it. Otherwise, thanks everybody for attending. I'll be here, and if you can respond to it, I can just share it anyway if you're interested in this one. And if you're asking how to integrate it, the instructions on how to integrate it is properly given here. See, for setup instructions for Claude, ChatGPT, etc. See this integration guide here. This one here. Yeah, I've just given it in the chat. All right then. Thanks everybody. Thanks for your time and have a
Thank you,
great day.
everyone. See you soon again, and hope you have a great Sunday, whatever is left of it. Thank you. Take care.